Okay. So once again, I'm just repeating myself, architect Jennifer, based in Chennai. I have my own practice here in Chennai where I do projects relevant to architecture, interior, any parametric consultation, etc. And apart from that, I have been part of design interventions as an associate for the past 3 years. And over the period of time, I have been part to share my knowledge in RHINO Grasshopper and parametric design. A little bit about design interventions. We are a team of architects and educators across the country. And we have been teaching for the past 4 years any concepts relevant to parametric and computational design. Our studio is also based in Chennai. And we normally conduct different workshops and courses. And also we are open to teaching to colleges and offices relevant to parametric and computational design. So over this period of 4 years, we have covered 4,000 plus participants through workshops that we have conducted. And today is one such day where we are going to get an idea of what is parametric design and also get a light insight on the software where we try to understand how the interface works and look into some examples that is going to help us in certain architectural workflows. So let's get started. First, we're going to have a quick 5 minutes presentation, just so that anyone who's completely new to the term parametric architecture, you get an idea of what it exactly means. So what is parametric architecture? One of the common thoughts that we have, like parametric architecture or parametric design, is something that is very, very widely used these days. And we commonly think that it is something to do with a lot of curves or to do with organic and fluidic structures. Or whenever you look into the building of Zaha architects, we feel like that is what parametric design is. To be more specific on what parametric design is, it is not the outcome itself. You can have very simple boxy designs, which is also parametric. So it is not constrained to what is the final outcome, but parametric is more of a strategy or an approach you take towards design, where instead of creating a 3D model, you would rather specify certain parameters based on which the final design outcome is generated. So every time you change these parameters, you're going to get an entirely different outcome that will have an entirely different form or a function. So this is what in general parametric design is. It is more of an approach rather than the outcome itself. A quick illustration to show the scene is this bottom image you're seeing. So the first circle is the user, that is us. And then we have certain parameters that runs through an algorithm to give you an output. Every time I change these parameters as a user, I will get a new outcome here. So this way you will get like thousands of different outcomes and you can decide what is the final design that you want to go ahead with. Now, instead of doing these parameters by yourself, where you get thousands of outputs and you get confused, what is it that you want? You can do something called as generative design, where instead of changing the parameters by yourself as a user, you introduce a new genetic element, which will start controlling the parameters and tell you which is the best output. So that is another concept, which is like a slight upgrade from parametric design. Instead of me setting the parameters, I just have an algorithm running and the algorithm itself will tell me what is the best possible outcome. So today we'll be seeing examples and exercises that is going to be relevant to both of it, where you get more clarity on what I'm saying. But to show you a quick idea of what exactly we mean by parametric design is, let us hide this. Let's just go to the top viewport. I hope you guys can see my RHINO screen. That is what I'm sharing right now. In case you aren't able to see that, just let me know. So I have a RHINO and Grasshopper interface in my screen. Normally, let's say I'm doing some kind of model, maybe something really simple. If it is AutoCAD, if I were to create circle, I'll just type circle and create one like this. That's it. So this is what you say as drafting or basic 3D modeling, where you type a command and you create an object. The same object, when you do parametrically, we will have an algorithm like this. Let me switch on the preview, where I specify the center point and I have created a circle of a specific radius. And every time I decide to change it in terms of these two parameters, that is the center of the circle or the radius of the circle, I have a possibility to do that. Whereas the circle done in RHINO, if I have to change the center or the radius, I'll have to delete it and create a new one. So that is the concept of parametric design. The same thing can be done as a 3D model as well. But when you're doing it parametrically, you have the option to change every single aspect that you have specified in design. This is only for a circle. When you imagine it in the scale of architecture, the level of complexity is going to be way, way bigger than what any modeling software can imagine. Another quick example is this one. So we have an algorithm here where we create a simple column with 4 circles that you are seeing, the 4 big circles that you're seeing. We are creating a column with that. And there are these parameters which helps us to change the radius of all of the circles involved in the column. And every time I change it, I get a different outcome. Like every change in the circle or every change in the position of the circle in terms of its height, I'm automatically getting an entirely different result. So this is what parametric design is. Also, the algorithm has 2 aspects to it. There is the design and there is the preview setup of the final outcome. So this is just a quick idea of what parametric design is. Getting back to the presentation. So right now I'm sharing my presentation slide. So now that we have like a quick idea of what is parametric design, let's take a look at 2 different examples. And the examples that we have chosen is one called the Sagrada Familia. It is something that was, or it was a design that was approached in the early 1900s. And a more recent example, which is a Tulum railway station. So let's take the Sagrada Familia that was designed by Antonio Gaudi. As I mentioned, it was designed in the early 1900s, which means definitely they did not have a computer or grasshopper to come up with parametric strategies. So what the designer had done here is, as I told you, it's more of an approach than the final outcome itself. He approached it using the concept of catenary arches. Catenary arches just, if you hold a chain, like the 2 ends of a chain, you get a natural curvature that is formed due to the gravity. So this natural curvature, you call it as a catenary arch. It's just like, the curve you get when you hold the 2 ends of a chain. Now, when you invert a catenary arch, the structure is considered to be stable in compression. So what the designer had done in the early 1900s was, he designed an entire church with the concept of catenary arches, where he created physical models. So if you take a look at this image on the bottom right, you'll get a more clear idea. He has created a physical model with a lot of different threads that is hanging due to gravity. And also he has small bags of weight that is hanging at different positions. Now, why this is parametric is because when he creates this physical model, he has 3 parameters that he can change. One is the length of the chain that he uses. Second parameter he can change is the distance between the anchor points. And third parameter he can change is the amount of bags he is using. So these 3 elements of his design process was parametric, and hence you consider as a parametric approach. Same thing can be done using Grasshopper, which makes it a lot more easier than the complexity you're seeing. And also what the designer had done is, you can only create a catenary curve. If you want to invert it and use it in an architectural example, you just take a picture of it, and he inverted the picture and he started sketching on the inverted picture of catenary arches. In today's world, with help of Grasshopper, this has become way more easier. So another example algorithm to show you how it works. So let's try it on a single curve first. So you have the same three parameters. And every time I reset it, you can see I'm getting an animation here. I can also flip the direction from positive to negative. So when I flip it to negative, I get a real-time capillary curve. And when I flip it to the positive direction, I get the curve which is inverted and suitable for an architectural structure because of its compression properties. Same thing, I can take a preview with these multitude of curves, which is similar to the idea of how the Sagrada Familia worked. And again, if I were to reset it, I'll get something like this. And if I were to flip the direction, I will get an outline of the form of the church. So moving on to another example is the Tulum railway station, something more recent. So over the period of time, there has been development of a lot of parametric tools where you see a lot of different examples. The reason we took Tulum railway station is because it has certain parameters which we will be exploring in the session today. And also it is something you definitely require the power of a grasshopper or some kind of computation tool. So one very interesting parameter of the Tulum railway station is how the roof was designed. The roof was first analyzed for the amount of radiation that will hit on it. And once the radiation was analyzed, an opening pattern was designed that will match the amount of radiation. So if you look at this analysis image, the red color represents the hottest region, blue represents the coldest region. Wherever the region is hot, there's a smaller opening size, and wherever the region is cool, you have a bigger opening size. So this is a very interesting strategy that they have used as a parameter while designing, and is also giving us more insight on how much tools like Grasshopper and RHINO can help you in determining the parameters. If you're using like physical models, you have a lot of limitations to it. It's not possible to do an analysis of the environmental conditions, etc. Grasshopper and RHINO is going to help you with that. And finally, moving on to design tools, we are mainly looking into RHINO and Grasshopper because it is very widely used compared to any other parametric tools. And also you have a lot of different plugins and resources available online, which makes it easy. Like any kind of strategy you want to try, you will most likely be able to find a plugin which helps you set those parameters. So in today's session, we are going to look into the introduction of both the softwares RHINO and Grasshopper, and we will see two main examples. One is we create a pavilion with a parametric pattern on top of it. Second, we use the strategies of generative design to come up with a skyscraper tower, which is optimized for the amount of radiation. So the form of the tower, like how much amount of twist or how the design is created, is going to be determined based on the radiation analysis. So these are the two things we are going to see today. I hope all of you have RHINO installed for today's session. Let me just open up a completely new document. So once you open RHINO, it would look something similar to the interface you're seeing in my screen. I'm just going to start with the basics of how the interface works and also how to create curves and surfaces, so that when we move on to exercises, you will be able to follow through that. If you are a complete beginner, this will be perfect because I'm starting with the interface. If you're someone who has a basic idea of how RHINO works, it's more or less going to be a brush up for what we are going to see next. So starting off with the interface, before that guys, since it is a live session, please make sure you do take the maximum advantage of it. Any questions, any doubts, we'll have like a little bit of 5 minutes break in between. So whenever you try something out, if it is not working the way I'm showing you in the session, feel free to share your screen, feel free to ask any questions and make sure it is sorted. But when you don't have any questions, please make sure you're on mute. When you have a question, you can unmute yourself and ask the question you want to be sorted. So to start off with the interface, RHINO has a 4 viewport interface in the sense, unlike SketchUp and AutoCAD, where you just view one aspect, it's either the plan or the 3D modeling viewport. RHINO is capable of showing all the 4 different views while you're working. Top is for plans, front and right are for the elevations, perspective is for the 3D model. So if I were to create something in perspective, automatically the model appears along with the plan in the top viewport and the elevations in the front and right viewport. If you want to work in a single viewport, what you can do is you can just move your mouse next to the name of the viewport. So if you look at my mouse, it's exactly on top of perspective. Just move your mouse exactly on top of the viewport's name. Double click on it. It will expand that into a single viewport. If you want to revert back to 4 different viewports, just repeat the same. Move your mouse again to the viewport's name, double click on it. It's going to revert back to 4 different viewports. So depending on whether you want to work in single or 4 viewports, you can choose between that. I'm going to work in a single viewport for now. So I'm double clicking on perspective. It is expanding with the single viewport here. 2 things I wanted to know regarding viewport is one, the style in which you are seeing the outcome. Right now, even though I have created a box, it is only showing me the outline of it. If I want to see the faces, the edges a little bit in a different style, just click on the small arrow next to the viewport's name, which is this one, and then choose the style you want to work with. Currently, it's wireframe, which just shows me the wireframe edges. I'm shifting it to the shaded mode, which is going to show me both the faces and the edges. Okay. You can also try out different styles, like rendered mode gives you a quick clay-like render. You can try the Arctic mode, which also gives you a clay-like render with slightly better shadows. And you can try the ghosted mode, which shows the faces and the edges. See what style you prefer to work with. I would be mostly using the shaded mode. It's the most convenient to see the faces and the edges. Third thing I want you to know regarding the viewports is the navigation in it. So first navigation is how to orbit. Just right click and drag. You will be able to orbit. If you want to pan, you hold down to shift key in your keyboard and then you right click and drag with your mouse. It will help you to pan. Zooming in and zooming out is using the scroll wheel button. You scroll up, zooms in, scroll out, it zooms out. I repeat again, orbiting is by right clicking and dragging. Panning is by holding down the shift key and then right clicking and dragging. To zoom in and zoom out, just use your scroll wheel button. I'm going to switch back to 4 different viewports. Next, what we are going to see is how to access any tools in RHINO. Any tool that I will be accessing to teach in today's session, tools as in any action you want to do, like create a box, create a circle, create an array, any kind of command or tool you want to access. It's either going to be using the command box. If you're familiar with AutoCAD, this is going to be really comfortable for you guys. It's very, very similar to how AutoCAD works in terms of the command names and also in terms of how the interface is going to be, right? So that's one really good thing about the command box if you are a previous AutoCAD user. Another way I will access the tools is using this large tool set that you are seeing on the left hand side. So it's either one of these ways I will access how the commands work. Let me just show you one quick example of a command. So what you can do is you can either click on the command box and type the command name like circle or rectangle or anything. Or what you can do is if you know exactly where the tool is located on the large tool set, you can just click on it as well. You hover your mouse on these icons, it will just give you a description of what each icon is going to do. So either ways you can select. I'm clicking on this circle. As soon as I do that, look at the command box. It will become active and will start guiding me what I have to do. If I want to create a circle, it will ask me to specify the center of it. I will just click a point in my top viewport. Then it will ask me what is the radius of the circle. You can just eyeball and click it in your viewport, or if you have a specific radius number that you want to incorporate here, you can type it also. So let's say I want a radius of 15. I'll just type 15 in the command box, press enter, command is completed. That's it. So the moment the command box is inactive, it means that the command is executed. I'll show you one more tool so that you get a little bit more familiarity to it. So let us say I'm going to try the box itself once again. So I'm going to choose this tool called as box, which is here, or you can type the command box. Look at the command box, it is asking me the first corner of the base. So it becomes active and starts asking me what I have to do in order to create a box. It's asking the first corner of the base. I can click anywhere. Look at the command box, it is updating and asking me to specify the other corner, or I can specify the length of the base rectangle. So it's up to me whether I can give the other corner as a point or the length. Let's give the length. Let's try 25. Enter. As soon as I do that, it becomes active, asking me the width of it. So width, let's give maybe 15. Enter. Now look at the command box. It is asking me for the height of the box. You can again give any height, or you can just click it. Let's give a height of maybe 35. Enter. Command box is inactive. I have the final output in my perspective and my top other viewports. So that is pretty much how we go about accessing any tools in RHINO, either using command box or the last tool set. Just make sure you know the command name or you select the tool. Follow through the command box guidance. You will automatically get the result. All right. Any questions by the way until this? No. Okay. Okay. So now what we are going to see is we are going to look into two exercises for today. First is a parametric pavilion. To do that, we should be able to create an organic surface in RHINO. Organic as in a surface with some curves in it. So we'll see how to draft a curve and create a surface. And then we will use Grasshopper to add the parametric detail out of it. So what I'm going to do is I'm going to select all of this and then delete it off. To create curves, let us start with the top viewport. It's easy to draft curves in the top viewport. One of the easiest ways is using the technique called as rebuilding. So what rebuilding technique, okay, before we move on to that, just running through the questions in the chart that I just received. First is how to set the units and how to make it visible near the cursor. To set the units, first check what units you are working in. You can find that in the bottom left of your interface. So if you look at the arrow mark that I have annotated, you can see in the bottom left, my unit says it is in meters. If you do not want it to be meters, so after you check, you want to change it, just type units in the command box and press enter. Takes you to this interface where you can specify what units you want to work with and then hit OK. That is one thing. Second, getting the details near the cursor is a setting I have made in RHINO, like these numbers and things. You can do that by going to document properties. Just type document properties in the command box. This is the official settings page of RHINO. So any interface like the background color or the rendering mode or the kind of settings that you see in an interface, if you want to change it, you can always go to document properties and under the mouse or modeling aids, I'm not exactly sure where I have set it. Just a second. Yeah, under the modeling aids, click on the small arrow you will have cursor tooltips. Just make sure you have these four settings on. These four settings is what is giving me the indication of the position of the mouse or the length and width of it. Right. So I'll repeat again. Just go to document properties. You will find the modeling aids. Click on the small arrow. Choose the cursor tooltips inside that, and you'll be able to find these things. Make sure that you have the same setting as mine. What is the tolerance in units? Tolerance is basically whenever you work in a modeling environment, two objects might not necessarily be touching exactly one above the other. So you have a minimum tolerance. If two objects are within that limit, so let's say the tolerance is 0.1. If two objects are within the distance limit of 0.1, like this, they are considered to be in the same position. So you can leave it as it is in default. You don't really have to change it. You hardly require that kind of settings and modifications. But in general, any modeling software, tolerance means the minimum distance within which the objects are considered to be in the same location. That's the basic idea of it. Okay, so let us start with the basics of curve drafting. So I was saying how rebuild is one of the easiest methods you can do for creating curves. So what I'm going to do is I'm going to start with drafting a line. To create a line, type the command line. As I said before, the commands in AutoCAD, most of them, let's say 90% of the AutoCAD commands will work in Rhino under the same name. So you can try it out, like just experiment with that. To draft a line, type the command line. It will ask you the start point and the end point. So just give a starting and an ending point. You can create a line like this. If you want a straight line along the X and Y axis, you can temporarily activate the ortho mode. How you can do that is once again typing line, starting point. For the end point, instead of moving freeform, I'm holding down to shift in my keyboard. When I press shift, my mouse will only move along the X and Y axis. If I release shift, it will automatically move in 360 degrees. So I'm holding down to shift and then giving the endpoint along the X axis by left clicking with my mouse. I automatically have a straight line. Now, every curve has the concept of control points and degrees. Whenever you select the curve, it will pop up some points on the curve, depending on what curve you have. So for line, it's just like 2 points on left and right. And if it is like I'm creating a rectangle, it will have 4 points in each corner like this. If I create a circle using the circle tool in the last tool set, it will have 8 points. So depending on what curve you are creating, the number of points you're seeing on it will change. These points are called as control points. Control points are nothing but points that can help you edit the curve. So if you select the curve and pick a point, you can edit it individually to change the form of the curve like this. Okay, so this is what or how a control point is helpful. Now to edit it, what I'm doing is I'm selecting the point and using a tool called as gumball. So you should ideally see an arrow like what you're seeing in my screen. It's called as gumball. If you do not see it, just re-ensure your settings at the bottom of your screen where I'm annotating in red color. You can see a term called as gumball, which is in bold, which means the gumball is switched on. If I switch off the gumball, I don't see the arrow. So just switch on gumball. And what gumball is going to do is it is going to edit something on your modeling environment. Edit in the sense I can pick a point, move it along the X and Y axis. So just select the point, click on the arrows of the gumball, like give a single click and drag. It's automatically going to help you move here. A little bit more about gumball. A gumball, when I switch to perspective, you can see the full shape or the proper form of the gumball. It's a 3-axis colored arrow, looks like a gizmo. The colors represents the axis. Red represents the x-axis, green represents the y-axis, blue represents the z-axis. If I click and drag using any arrow, it's going to move in that respective axis here. Okay, so gumball is going to help you move with respect to the arrows. The colors represents the axis. Red, green, blue is X, Y, Z. Click and drag to move in the respective axis. That's it. Let us try it once again. Let's go to the top viewport. I'm creating a line, starting point. For endpoint, I'm holding down to shift to restrict my movement along the X and Y axis. And then I'm clicking to create a straight line. I can always select the curve and edit it using the control points and the gumball here. Now, a line has only 2 control points. If I have more control points, I can break down this geometry into a more complex form. So what I'm going to do is, I'm going to increase the number of control points here. To do that, I'm using a new command called as a rebuild. Make a note of it. We would be using this, or generally whenever you want to create a curve. Rebuild is a common term you would be using in Grasshopper to create curves. So I repeat again, the command name is rebuild. Look into the command box to check the spelling of it. It will ask you to select the curve, which I have done, and then press enter. It will open up a dialog box here. And inside the dialog box, you will have a setting called as point count. This is what specifies the control points. There's a number in the bracket that indicates the existing number of control points, which is 2. Then in the dialog box, you can specify how many control points you want to have. Let's try maybe 5 control points. There is another setting called as degree. Existing is 1, which is mentioned in the bracket. I'm going to retain the same degree as 1 for now. Let's just play with the control points and then we will see how to use degree in a bit. So I'm retaining the degree as 1, point count alone I'm increasing. Hit OK. Now if I select the curve, you can see I have a lot more points here. I can now pick up any one point, or you can pick up multiple points together, up to you. And then when you edit it using the gumball, you can see that I'm getting a different, more complex form or a more interesting geometrical breakdown here. That's it. So this is what a control point is going to do. You can use a rebuild to add more of it. Another thing I want to do here is I want the curve to be smooth. To control the smoothness of the curve, you will be manipulating the degree of it. So right now the default degree is 1. You can change it by again rebuilding. So rebuild helps you control both the control points and the degree. Just go to rebuild. Point count, I will keep it as 5. Degree is set to 1, which is giving me these sharp polyline curves. If I change it to 3, automatically it gives me a smooth curve. So degree controls the smoothness. 1 is if you want to have a polyline. A degree of 3 is when you want to have a smooth curve. You need to shift between that, seeing what kind of curve you're trying to create. I'm switching to degree 3. Hit OK. I have a curve like this. Once again, we can manipulate the control points if you want to change the shape of the curve. So to quickly brush up, there are 2 elements when you create a curve. You have the control point and degree. Control point is the number of points you have on the curve that helps you change the geometry of it or the shape of it. Degree controls the smoothness of the curve. Degree 1 gives you a polyline and a degree 3 gives you a smooth curve. That's it. This is one simple way of drafting a curve. An even easier way is you can use this tool called as control point curve. Go to large tool set, second row, second icon, control point curve. This is like way super easy. Just click on it. Keep clicking on the points where you want the curve to be created. Press enter. That's it. You have the curve. If you're not happy with the curve, pick a few control points and edit it. That's it. Okay. So I repeat again, to create a curve drafting by just placing the points directly, use this control point curve that you can find in the large tool set, second row, second icon. Just keep placing points where you want the curve to be created. Press enter. You will get a curve like this. When you select, control points are visible in case you want to modify it a little bit more here. That's it. So that's pretty much how you go about creating curves in RHINO. Any questions until this? And meantime, I'll just run through the questions that is mentioned in the chat. Any other questions apart from that? Also, just let me know, ma'am, how to work in levels like we work in Revit, and how to make sure the model drafted lines are in one level that is not in it. And how does projecting work? Okay, to answer the first question, how to work in levels, you do not have the concept of levels in RHINO. RHINO is a modeling software that is, let's say, going to replace AutoCAD in terms of 2D drafting, and it can replace any modeling software like SketchUp, 3ds Max in creating 3D models. When you want to work on BIM models, or when you want it to be precise, like in terms of traditional structures of how the elevation levels work, how the wall thickness is, the window blocks, all of those, like if you're someone who work in Revit, it's going to be quite different on how the concept of RHINO works compared to Revit. And to again answer your question, you do not have the concept of levels in RHINO like how it is in Revit. You just work at different heights in perspective to get that result. How to make sure your model is drawn in one level? When you're working in the top viewport, it's automatically going to be in one level. In case it is not in a single level, let's say by mistake, something has happened that, few points are above, few points are below, something like, something weird happens and you have them at different levels. What you can do is, you can just select everything, and you can use this command called as setpt. Again, look at the command box for the spelling of it. It's called as setpt. Select the curves you want to flatten or have it in the same level. Choose setpt. You will get this dialog box. You need to choose which axis to flatten. Most likely our flattening will be in the z-axis level. So select z-axis alone in the settings, hit OK. It's going to come down flat to the same level. If you want a different height, you can change the height in front viewports like this. Okay, you can give a different height, or you can just snap at an existing height here. I repeat again, the command to use is called as setpt. Again, command box for the spelling. You get a dialog box where you can choose which axis you want to flatten. Choose z-axis if you want to flatten like how you are seeing in my perspective right now. And then you specify the position where you want the flatten to sit. That's it. Could you please repeat the curve? Can we change units in between modeling, and will it change the modeling to corresponding unit after modeling found? Will you work on the interior step? Okay. Repeating the curve part, I'll come to it in a bit. Answering the other questions first. Can we change the units meter to feet? Yes, you can do that in between modeling. And you can also specify whether a model has to be changed in terms of scale on the units changes. So type units, choose what units you want from meters to, you can go feet or any kind of units, and choose hit OK. It will ask me whether you want to scale the model from meter to foot. You can choose to say yes or no, depending on what you want to do. Right, that's it. And I'm just going to cancel it for now. But if you want, you can do that too. And answering the next, after modeling a form, how will you work on the interiors then? Shahidullah, just remind me of this question towards the end of the session. You will get a better clarity when we work on a few models, and then I say how you can go about the interiors. Right now, when I say, you might not have a complete idea of how a model works, and me saying how interiors will also work will just be confusing. Just remind me this question towards the end of today's class. I will dive a little bit in detail how you go about the interiors of it. And yep, so answering the other question, can you repeat the curve process? Anyone who is not clear with curve drafting, just run through it again. Meantime, guys, whenever you feel like, you just have time during the session to practice, feel free to work along with me. That's why I'm going a bit slow. And also by the end of these 3 hours, you will have some outcome to look at, because you have spent a good amount of time trying to learn or listen to something that's new. So make sure you do try to practice along with me if the pace is suitable for you. So for curve drafting, we saw two techniques. One is rebuilding. You can create any line or a curve, doesn't matter. Any curve. I'm just creating a line using line command, creating a straight line. Type the command rebuild. Specify how many points you want on the curve. I'm going to give 8 points, and also specify what is the degree you want. Use degree 3 when you want a smooth curve, and then hit OK. You will have more points on the curve. Pick up one or more points and start editing it. You will get a curve that looks something like this. You can edit more points and just changing one control point. Another way is you can use the control point curve that you find on the last tool set. Snap at different points. It will automatically create a curve passing through all of those points. That's it. Press enter once you're done. Again, the curve we have created, if you're not happy with it, just pick a control point on the curve and edit it using the gumball. All right, so now moving ahead, what I'm going to do is I'm going to create a few more curves so I can show you how to come up with surfaces out of it. Okay, we're going to see a quick technique called as lofting, but before we do that, I'm going to create one more curve here. So creating a copy, you can do that in Gumball. If I just click and drag in the X and Y axis, it's just going to move the curve. If I want to copy it, hold down to Alt in your keyboard. And while you're holding down to Alt, if you click and drag using the gumball, it's going to create a copy. I repeat again, to create a copy with gumball, hold down to Alt in your keyboard, and then you click and drag any gumball like the arrow, it will automatically create a copy. I have one copy here. I'm just going to adjust it. I want the copy to look different than the original curve. So I'm going to manipulate it a little. You can manipulate more control points, but just as a technique, I would personally prefer to always have less control points where only a few of them are edited. It will give you a more smooth, sleek result compared to when you have a lot of control points and you have, like, let's say, a lot of bends that you're trying out. It won't have that much of a sleeker finish. It's just a personal preference. You can see what kind of editing you want to try. Anyways, I just picked up 8 points, edited just 1 or 2 to create this curvature. Now, when I look at it in 4 viewports, a small hotkey that you can use here is if you have your curves, very farly placed, like when you look at it, it's not close enough in your viewport. Rather than manually zooming it like this, just select the object, type in this command called as ZSA. Look at the command box, it's ZSA, short form of zoom selected in all the viewports. So type that, press enter. It will zoom whatever object you have selected in all of the 4 viewports, making it easy for you to navigate and work. Okay, repeating, the command is ZSA, just select and press enter. Now, the curve looks interesting in the top viewport. I like how the curve looks in the plan, but in the elevation, it's very flat. I want it to be a little bit more organic in elevation as well. So what I'm doing is I'm selecting the curve, picking up a control point. Whenever you want to edit in the elevation, a suggestion will be to make sure you have all the 4 viewports visible. So what you can do is you can select the curve and pick up the control point in the top viewport. And when you want to edit the height of it, shift to an elevation viewport where you have the axis of Z in the gumball. Just click and drag in the Z axis. So I'm working in the front viewport right now. When I'm working in front viewport, I can simultaneously visualize how my perspective is going to start to look. I'm going to repeat that again for the second curve. So I'm going to pick up a few points. You can pick one or more points you want to edit. I'm selecting the points in the top viewport because it's easier to know which point you're editing that way. And to change the height, move your mouse to any one of the elevation viewports where you will have the option of editing in Z-axis. Click and drag only in the Z-axis. If you click in X-axis and drag, your plan is going to shift. So if you don't want the plan to change, always make sure it's only the Z-axis you edit. And also don't use any grids that you're seeing or a freeform move. Always make sure it's only the arrows. This will further avoid any weird transformation. So there was a question, how do you make sure you don't change the axis of it, you don't change like, randomly going in space. This is how you do it. You try to use the gumball arrows as much as possible to avoid that happening. And yeah, so I'm just going to edit this a little bit more. Take a look at it in perspective. I think I'm happy with how the perspective view of this is coming up. Once you're happy with the curve, like you're completely satisfied, okay, this is the curve I want to use for creating the surface, you can create a surface out of it. The command I am going to use for surface is the command called as Loft. Look into the command box for the spelling. It will ask you what are the curves you want to loft. I'll select these two curves, press enter. You will get a dialog box here. Just hit OK in that. I will get a surface that looks something like this. That's it. I repeat again, let's delete the surface. To create a surface, in this example, I am using Loft. There is a few criterias where Loft will work. Loft will work when you have minimum two curves that you want to use for creating surfaces. Maximum doesn't matter. You can have 220, 200, doesn't matter. But minimum, you should have two curves between which you want to create the surface. That's the first criteria for Loft. Second criteria is make sure the curves that you're using do not intersect each other. It will ensure that you have a clean result. Sometimes it will work if you intersect, but I do not recommend it. For better surfaces, make sure the curve and the curves you're using for Loft do not intersect each other. And then just select the curves, have the command Loft, hit OK. I'll get something like this. That's it. Now, I was saying how you can have multiple curves as well. Let's try a small variation to it. I'm just going to move this aside as maybe the first experiment. Let's try a small variation to it. The variation, what I'm going to do is I'm going to add another curve to this. So if you look at the surface right now, it looks more or less like, if I were to consider it as an architectural element, it looks more or less like a roof surface. So this is probably the ground. The surface converges into a roof and then converges back to a ground plane. I would want it to have a wall-like surface on the back as well. So I want the surface to continue till the bottom like this. When I want to do that, I'm just going to add another curve. So what I'm doing is I'm creating a copy of it in Gumball. I'm creating a copy in the top viewport, holding down to Alt, clicking and dragging using the Gumball like this gives me a copy. So hold on to Alt and then use the Gumball. It's going to give you a copy. The copied curve, I want it to lie completely flat in the ground level. When I want to do that, we just saw the command a few minutes ago. It's called as set PT. Just select the curve, type in the command set PT. In the dialog box, I'm selecting the axis Z, hitting OK on that. It will help me to snap at the ground level. So I can specify where I want to flatten and snap it. And just snap at the ground level. I have three curves like this. I'll repeat once again. You have an organic curve that you want to flatten. Just use set PT. Select the curve. In the dialog box, choose Z axis. Click where you want to place it. You will have a curve like this. Once this is done, I want to create a surface between them. Let's select all the three curves. Type the command Loft. I have a surface that looks something like this. And in Loft, you can also hit OK right away, or you can play with something called as styles in that. If I choose a loose style, the preview will change a little bit, like it loosens from the curves in between the edges. If I choose tight, it's going to be perfectly tight. Straight will give me straight cross sections. I can choose uniform. See what style you like best. I like normal itself. You can choose a different one if you want. and then hit OK. If you're confused what style to choose, just create a variation. Let's just move these aside. Let's select and loft it together. I'm going to choose a loose style maybe. Hit OK this time. I have another variation. Now let's do one thing. Let's just have a quick visualization of what we have done. Select ZS enter. I'm going to zoom in. And I'm going to put it to the Arctic mode to visualize how my surface looks. And you can also use this command called as turntable. Turntable helps you give a 360-degree animation just for like a quick visualization. And then press enter. You can see it rotates in 360 degrees. Comes with a dialog box where you can control the speed of rotation. You can also control the direction, whether it has to be clockwise or anti-clockwise. I'm just going to choose, whatever works best for me by playing with this slider. And that's it. I have a clear preview of how my surfaces are created. So any questions until this? We are going to see one more thing before we take a quick 5 minutes coffee or a refreshing break. Before that, any questions? Type out in the chat. I'll just run through it. Can you repeat the use of the tool ZSA? I think we just did. If you didn't catch it, just select whatever objects you want to zoom and type ZSA in the command box and press enter. It's going to zoom in all of the viewports. That's it. Next question would be, can I select all the points and bring it back to flatten on in one plane? Yes. Do you mean select all the points as in, let's take this curve. Let's do one thing. Let's move this surface also aside. All the points as in, do you mean you want to select a few points and then flatten it to a different plane? Or are you asking whether you want to do for the entire curve? I'm not clear with the question that was asked by Shreya.
Like if I, like your last curve, which you copied, all of those are on the x-axis, right? Like that, if I just want to bring one point to x-axis from another curve.
You can do
Like,
that too, yes. So let us say only these 3 points are moved above. And I do not want that. I just want these 3 points to come down to the flat Z axis. Rest of the point has to retain its curvature. Just select the relevant control points, type the same command, works the same way, choose the axis as Z, hit OK. And then specify the location as to where you want to place it in the Z axis levels, and you get the result.
okay, thank you.
Welcome. Where is the loft on Mac? You just type loft as a command. It should work in Mac as well. If you are not able to find it, let me know. Maybe. Thanks. Okay. Ma'am, after rebuild, I'm not able to select points or change or bend. When you select the curve, do you find the points visible? This is answering the question from Swapnil. Points are not visible. If you do not see any points, can I know which version of RHINO you're using? This is a question, RHINO 5. Okay, that's the reason. RHINO 5 is a very outdated version. Right now, the recent one is RHINO 7. So what you can do in RHINO 5 is select the curve and then choose this tool called as show object control points. If you do not see this tool, the command alternative is points on. Just type points on and then select the curve and press enter. Control points will definitely be visible. So you need to do this additional step when you're using the version RHINO 5. How does project work? Just a minute, I'll come to that. How to add trees lighting in model. Trees you can download from any kind of public blogs. Like you can download a 3ds Max block or you can download a SketchUp warehouse model. And after you do that, go to file, choose import, and under import, choose the format of, you can see that all of these different formats will work. You will most likely import it as an OBJ file if it's from 3ds Max. If it is a SketchUp file, you can directly import it from SketchUp. That's it. And yeah, that's how you go about trees. Lighting, it needs to be done in the rendering engine. Whichever render engine you're using, you need, if you're using V-Ray, you will have light settings in that. Lumion, you'll have light settings in that. You need to use that. I'm not able to see the Loft option dialog box, Ritika Segal. You will see the Loft option dialog box when you select the curves and then type Loft. You should get this dialog box as a preview setting. You will not get it right after typing Loft. After typing Loft, the curves have to be selected, and then when you press enter, you get this dialog box. Just retry it and let me know if it is not working. I cannot find the bottom toolbar which has Gumball, OSNAP. Ashish, are you using Mac? If so, let me know. And for Swapnil, can I change it? Change it. What you want to change? You want to change from Rhino like to a newer version? Swapnil, just clarify your question. Meantime, Ashish, I am on Windows. If you do not find the bottom tab, just a second. Just type Gumball in the command box. This is for Ashish. If you do not find Gumball or Snap those tools, just type it in the command box. You can choose on or off in that. If it is set to off, you can see automatically my bottom is also getting updated. I'm not able to see it. You want to toggle it on, just type Gumball and switch it on. I'm not exactly sure how you can bring it to your interface, but for now, you can use this as a makeshift option for switching on Gumball. How to create a dome and edit it. We'll come to that. Creating a dome, I'm going to show you another example of piping. So we'll see how that works. Can we transport models from RHINO and other softwares? Yes, you can just go to File, Export, or File, Import. If you want to bring from other softwares, import. You want to take from RHINO to a different software, export. Just like any modeling software works. Same copy when I select green line to get infinitive while transfer breaking into polygon. Okay. Okay, so let's do one thing. I will go through the chart question of how does project work. And then I will show you one more technique. We'll have a 5 minutes break. Any issues where you are using it and like there's a question, I'm not able to make a copy of the line, etc. Those kind of things where you would like to share your screen, we'll have a 5 minutes question answer session after that. Okay. So meantime, others can, those who are clear, you can have your models ready for the next part of the exercise where we'll be creating some parametric details. So just a small teaching portion before I dive back into the questions mentioned in the chat. So one example I'm going to do is we are going to try some parametric pavilions. So let me just show a few examples. So when I search parametric pavilions, you will see a lot of different examples. Basically, you have a surface, and on top of the surface, you have some detailing. We're going to create a detail quite similar to this. We are going to work on prism-like details on a slightly different kind of surface. You can feel free to create organic, any organic surface, guys. You can do something with Loft that we have seen right now, or you can do something similar to what I'm going to show you next. Let me just open up the final result that we are going to do. So you will have an idea what is the next plan. Just a second. Okay, so this is the pavilion we are going to attempt. We are going to have an organic surface. I'm going to create something similar to this one. You can feel free to create a different one also using the Loft technique, up to you. Once that is done, I'm going to create these prism-like parametric patterns on top of it using the help of Grasshopper. So let me revert it back to shaded. I'm going to show you how to create this surface first, and then you can create the same one or a different surface and have it ready for the next part of the exercise. For creating the surface, I'm using two commands. One is I'm creating a curve using a command called as spiral. So I get a spiral curve. Second, I'm using a command called as pipe, which will help me get this kind of a smooth circle-like cross-section. So these are the two main commands I'm using for creating this surface. So to create a spiral, I'm switching to 4 viewports. When you create a spiral, it will be more clearly visible in the plan. So I choose to have it in 4 viewports to get a better idea. I'm going to use the command spiral. Look into the command box for the spelling. When you type spiral, choose the setting of flat. It will automatically give you a flat spiral curve in the top viewport. If you don't choose it, you will get a 3D spiral, which you need to do set PT again. Too many steps. So make sure when you select spiral or when you type the command spiral, you immediately choose the flat setting in the command box. It will ask you to specify the center of the spiral. It will ask you to specify the outer radius of it. And it will also ask you to specify the inner radius of it like this. So again, you can give it as numbers in the command box. I'm just visually eyeballing it. Also, if you do not get a single turn, there is something called as turns. You can change it to 3. That way you get like 3 turns. You can change it to 10 if you want more turns. I'm going to revert it back to 1. You will have that settings while you're doing the spiral. So I'm just going to change it to 1 single turn, and I have a spiral curve that looks something like this. I will repeat it once again, command the spiral. I'm choosing the flat option in the spiral command, giving a center, an outer radius, and inner radius here. That's it. I have something like this. If you look at this spiral curve, it does not go until the very interior. It stops somewhere in between itself. What you can do is really simple. Just select the curve. There'll be a lot of control points. If you don't want the curve to completely extend till here, just select a few of it, press delete in your keyboard. When those control points get deleted, length of your curve is also shortened accordingly to that. Not a necessary step. If you want to reduce the length of the curve, you can just pick a few control points and you can delete it as such. I think this shape works pretty good for the example here. Once you have the curve, I'm going to create a surface using a new command called as pipe. Loft is used when you have minimum 2 curves and they're not intersecting. In this case, I just have a single curve and I want a pipe-like surface. Pipe is nothing but gives you a surface like the name itself, like a plumbing pipe or an MS steel pipe. Basically, how or what reminds you of a pipe. Same exact thing it's going to create on the curve. Type the command pipe. Select the curve that you want to pipe. It will ask you to select a rail. A rail refers to the curve on which you want to have the pipe surface. Then the command box will ask you to specify the starting radius. And you will see that, one endpoint of the selected curve will have a preview of the circle or the radius of the pipe. You can once again type a number in the command box and press enter, or you can just eyeball and give a single click anywhere, like how much you want it here. It's up to you. You can always give a number, it will be more precise. For just doing something visually proportionate, I'm just randomly giving a bigger size here. As soon as I specify the radius for the first point, command box will update asking me the end radius, giving a different circular cross section at the end point of it. If you don't want the radius to change, just press enter twice. If you want a different radius here, type the new radius here, let's say 15, and then press enter. Enter again to complete the command. You will have something like this. I'll repeat the step once again for the pipe command. Step 1, create a spiral, or you can even create any curve like using rebuild or control point curve. No restrictions on that. Once you have the curve, use the command pipe by selecting it. Specify a radius. It will ask you the starting radius. Specify a radius for the starting point. Let's do 25. Enter. If you want the same radius to be applied throughout, press enter 2 more times. If you want a different radius at the end point, just give a different number, let's say 15. Enter. Enter once again for the preview to be applied, and you have the result. That's it. So this is pretty much how you go about creating the basic surface. A few more things I have added on here is compared to this one. First, I'm taking only the top surface for the example. So to take only one single surface, right now, when I select and look into it in the properties, it shows that it's a poly surface. I just need one surface, so I'm going to explode it using the explode command. Explode will basically break it down into individual faces. So just select the object and type explode. This is me adding some details to the surface. Again, not a necessary step. Feel free to do a different one also. And once I explode, you can see it starts getting selected as three individual faces here. Just going to delete this and this. I'm going to consider only this face. And also this curve is also no longer needed. Let's just move aside. Next thing I want to do here is the surface that I have here. I'm considering it to be a pavilion, which means there is going to be a ground level beyond which I will not have this curvature. Like look at the example pavilion that is done. You can see the surface is only until the ground level, so it sits like a pavilion. In this case, I have the surface going below the ground level as well. So what I'm going to do is I'm going to trim off the excess. You must be familiar with the concept of trimming from AutoCAD. Same thing, trim will help you to delete a portion of an object. Only thing, you're going to do it for a surface this time, not for a curve, but for a surface instead. So what I'm doing is I'm creating a line on the ground level. Observe carefully how the line is created. I'm creating it in the top viewport. Whenever you create in the top viewport, it's always on the proper ground level. And to trim it off, what I'm going to do is switch to the front viewport. I would prefer it in the shaded mode. You can see the curve perfectly defines the ground level, okay? This is a very important step. If you're planning to trim like how I'm doing right now, make sure you're doing the trim in the front viewport where the curve at the ground level and the surface looks like they are intersecting. In the top and the perspective, they do not intersect. Only in the front viewport, they intersect because of the parallel projection. So make sure you're doing this in the front viewport. Type the command trim. When you type trim, select the cutting object as the line on the ground level. Press enter after that. Then the command box will ask, what is the object you want to trim? I'm going to select the surface below the ground level. So when I click here, automatically gets trimmed. So I clicked it in the front viewport. Look parallelly in the perspective, it goes away. And then press enter to complete the command. I have the trim done. I will repeat it once again. The command is called as trim. It will ask you what is the cutting object. Make sure you select this line in the front viewport. Press enter. Then it will ask me what is the object to trim. Click the portion of the surface that needs to be deleted. Again in the front viewport. Press enter. You'll have a surface. And that's it. This is how it's going to look. So this is the surface I'm going to use in the next part using Grasshopper. Till now, whatever we have done, nothing is parametric. It's just a simple modeling software. Only when we are going to use Grasshopper, we are going to see how parametric is going to work. So before we do that, let's take a quick 5 to 10 minutes break. During which time you have any questions, you can go ahead. If you want to share your screen, you can do that too. But we will be back by 12:20 to continue with the session. So I will introduce you to Grasshopper and we will work on creating a pattern as you are seeing in my screen. So yep, and also guys, have a surface ready if possible. I will save and share this RHINO file. You can directly use it from here. You can use any one surface that we have done. Create any surface, no restriction, either something like this or randomly through curves and Loft, and then have it ready for the next part. Meantime, I will just save this file in the version RHINO 5 itself, since someone is using RHINO 5. I will save it in RHINO 5 version, share it across in the WhatsApp group. If you want, you can directly open that file and use that itself for the next part of the exercise. So just give me a minute. After I save and share, I will start running through the questions. Surface for pavilion. All right, so let me run through the questions. Um, I'm not able to, okay, please repeat the spiral. I think we just ran through it a few times. I hope it was clear in that. If it is not, just let me know again. I'll run through it now. Can we get a recorded session of this meeting? Yes, we are planning to do that, but I'm not 100% sure. I'll just check with the team and confirm before we wind up today. Okay. In case we are sharing the recording, I'll just confirm how we'll be sharing and everything. But I'll let you know towards the end of today's session. Please explain this again. I don't see that central line. Okay. So before I go into these questions, I think there was a question I didn't answer before, which is from Prakash. That is, I'm not able to make the same copy of any line when I select. Prakash, you can share your screen if you want to share and show, because when I see it, I'll get a better idea what issue you're facing. And then I'll move on to the rest of the questions. Prakash, can you let me know if you're about to share your screen? I don't see anything yet.
Yes, ma'am, I'm sorry. Just a second.
Okay.
My screen is visible.
Mm-hmm.
I've
Yes.
actually, unfortunately, had created this. I don't know how.
Okay. Can you put it in the
So,
shaded mode?
okay.
I think you might have extruded instead of creating a move. When you're moving it, be a little careful. Select any object. And when you see the gumball, make sure you always click on the tip of the arrow. If you click on that
Yes.
circle, that is this portion, it will probably extrude it. I think that's what might have happened here. So not
Yes, ma'am, actually. Just a second. What is happening? Suppose I'm just drawn this line and I am just giving the command rebuild. Then I just set it this. Okay. So
you don't see the points.
I'm just shifting. This is happening.
Don't click on the circle. You should not click on the circle. Always the tip of the arrow. One. Second, could you undo and do the rebuild once again? Also, guys, I didn't mention that undo is Control Z and to redo it's the Control Y. Okay, your setting seems fine. Hit OK. You are getting the points. Now click one point at a time and then move using the thumb ball arrow. Don't do the click and drag. Always click the point to select it. After you click the point and it is selected, use the gumball arrow by clicking and dragging the tip of the arrow.
Okay.
Is it clear?
Alt. By pressing Alt, it may be copy.
I didn't get it. Could you repeat?
Yes, ma'am, I get it. Thank you.
All right. Welcome. And Ignatius, ma'am, while transfer from RHINO to SketchUp, breaking into polygons like mesh, is there any other option to maintain in nerves? Not that I'm aware of, unfortunately. SketchUp works in the polygon concept, and RHINO, I think you have attended our workshop before, if I'm not wrong. So you remember that, how it works with NURBS concept. So I'm not really aware of a method where the NURBS object retain its NURBS object, that kind of a profile when it goes to SketchUp. It will break down to match the object type of how SketchUp works. I would normally suggest you to just use an alternate software. Once you are done with the model and you want it to be part of a bigger model, like you do an element in RHINO and you want to make it part of a bigger model or something like that. Please repeat the spiral. Okay, please this again. Okay, can you explain the trim? Okay, can you spiral? Okay, you should select plane, not able to trim, object with line as reference. I'll do one thing. I'll quickly brush through what we did for the spiral. Okay, if you're someone absolutely new, it's fine. If it's not coming exactly the way it is for me, that's absolutely fine. You can just open up the file that I have shared and work for now. I've also checked with the team for the recording, so I'll let you know regarding that also. Most likely we'll try to share the recording with you, right? But anyways, I'll just run through the spiral part. So to create this spiral, use the command spiral. Choose the setting of flat in the command box when you're typing the command spiral. Specify center, outer radius, inner radius. If you want, you can directly use the spiral curve. I want the spiral curve to be a little bit smaller. So I'm deleting a few control points by selecting and pressing delete in my keyboard. Once that is done, I'm going to use a pipe command to have the surface. Select the curve that you want to pipe, give a starting radius and give an ending radius. Once you are done specifying both, press enter. You will have an object like you're seeing in my perspective viewport. Now, to make it similar to a pavilion, I would not want this entire pipe. I want the circle, closed face deleted. So what I'm doing is, right now it's a poly surface. If I explode it using the explode command in the command box, just look into the command box. If I explode it, it will break down into individual faces like this. Just delete the unnecessary faces, and spiral also not needed. I'm just deleting it. I will have a profile which looks similar to this. One last step in making this into a pavilion similar to the image on the side is to have the surface below the ground level trimmed off. Create a line at the ground level. To create a line at ground level, just type the command line. Create it in the top viewport, something like this. After you do that, look at it in the front viewport. Make sure it completely passes through the surface. Like I have the surface and the curve. You can see curve completely cuts through surface. It should not be somewhere random like this, where the curve and the surface do not cut in front. Make sure they perfectly cut like how you're seeing in my screen. And then use the trim command. Select the curve first and then type trim. And then click on the portion you want to delete mandatorily in the front viewport. Don't click in any other viewport. Just click on the front viewport where it is intersecting. Click the portion you want to remove. So I click below the ground level. Press enter. You will have a surface like this. That's it. So you do spiral to have the curve, and then you do pipe to get the piped object. It will be a poly surface, explode it, and finally trim below the ground level. So you have like 4 steps in achieving the shape. Try to do this. If this is confusing to you, just try a different shape. Doesn't matter. All we need is a simple surface. Can't delete the opening surface of the tube. Also, spiral command has lot of curves. You need to check for 2 things. Opening, you need to explode it first. You might have missed on the explode step. After you explode, you can delete off the front faces. A spiral has a lot of curves like this means when you do the spiral command, after you specify flat and give the center and you give the radius, while you're giving the second radius, command box will have a turns option. Set it to 1. If you have it higher than that, you will have a lot of spiral turns on the inside. Just make sure the turn setting is set to 1 or 2 depending on how much you want to have. Can you please repeat the step where you initially generated the curve? I use the command called as Loft. Just select every curve and type the command Loft and hit OK in the dialog box. You will get a surface. Turntable video cannot be exported as an animation. You will have to use an alternate screen recording software to do that. That way you can have it as an animation. But RHINO does not have an inbuilt setting to export it as an animation. And I think the previous questions regarding how this is generated, I think I have cleared. And Shreya, I'm just seeing you have mentioned you're not able to view it in the shaded mode. If you're not able to view in the shaded mode, which is not yet sorted, feel free to share your screen. We will continue by 12:25.
Yeah, 1 second. Can you see my screen?
Yes, I can. Can you switch? Can you click on the small arrow next to perspective?
Yeah.
Just click on it with your left mouse button.
Yeah.
Do you see any options like wireframe, shaded, rendered in that?
So I see only wireframe.
I think your installation might be incomplete. After the class, just do one thing, just uninstall it and reinstall it. Most likely should be sorted.
Okay.
All right. Is it possible to increase the radius of center in spiral? Once you're done with spiral, you can't. RHINO is not a parametric tool. Grasshopper is a parametric tool. RHINO is just a modeling software, but much more advanced in terms of coming up with curves and organic surfaces. So what we're seeing is just like a 1-hour session where we see how to create these surfaces. But in RHINO, you can create a lot more complex examples. So that is where RHINO works. And to answer your question, no, it's a static modeling software. You cannot change it after the spiral is created. You need to redo the spiral command. Okay, so let us continue with the session. And also, guys, a reminder to have your mic muted when you don't have a question. Whenever you have a question, feel free to unmute and go ahead. All right. I'm just going to share my RHINO screen. So now we are going to start with a new interface, which is Grasshopper. So Grasshopper is where you get to create algorithms and set parameters for your design. So that is the parametric engine that is available inside RHINO. And you have this inbuilt only in RHINO 6 and RHINO 7. If you're using RHINO 5, Grasshopper is not inbuilt. You need to download it as a separate plugin. I would suggest anyone who's using RHINO 5 to upgrade. If it is not possible to upgrade because of your system constraints, then the only option is to install Grasshopper separately. For those of you who are using a more recent version, just type Grasshopper in your command box. It's going to open up a new interface like this. This is a file I already have open, but most likely your file should look something like this. If it is not, just go to File and choose a new document. It will open up a completely new file. I repeat again, just type Grasshopper in the command box. It will open up a new interface here. Go to File, choose New Document to make sure the interface is completely new. A small suggestion will be to isolate the surface you're going to use for pavilion. So if you're using the file that I have shared with you, you will see a lot of different surfaces. Or if you have experimented with a lot of surfaces, just isolate the one surface you're planning to work with. So if I'm planning to work with this one, I can hide the rest of it by selecting this object using a command called as isolate in RHINO. It will automatically have a preview of only this object. Rest all goes in hidden mode. If I want to unhide the remaining surfaces later, use the command called as show, show. It will bring back all the hidden object. For now, I'm going to isolate, selecting the object, tapping the command isolate. Not necessary, but it's up to you. If you want, you can do that. Now, starting with Grasshopper, the interface is going to be entirely different. I'll just give you a brief idea of how you're going to work within Grasshopper. First thing, it is not a modeling environment. It's a parametric engine where you can create algorithms. One more suggestion is, if you are completely new to Grasshopper, just take notes and try to grasp the concept as much as possible. When I share the recording at the end of the session, you can go through it once again and create or complete the exercise. For now, just try to grasp as much as possible when I am teaching. So first is in Grasshopper, you do not create models, you only create algorithms. To create any action in Grasshopper, you access something called as a component. To create a component, that is to do any action, to create a component, double click with your left mouse button, opens up a dialog box like this. You just need to type the component's name. Component is an alternative to commands you have in a software that helps you to model. In Grasshopper, the alternative is called as component. So let's do something really simple. Let's try to construct a point. To construct point, the component name is construct point. Select this one. Don't press enter. Select the point or the component name. And when you do that, you will get a box like this. I repeat, double click on the canvas. You get this dialog box. Type the component name called as construct point. Select the component. You get this component in here. Component will have three parts to it. You have the inputs on the left where you specify the requirements for creating the point. The output on the right where the point that is created will come here. And in the center, you have the name of the component. Okay, so these are the three parts to a component. Input on the left, output on the right, and in the center, you have the component name. Now, if I want to construct a point, it will ask me for three inputs. It will ask me what is the value to give in X, Y, and Z coordinate. If I give those three numbers, it will give me the point as an output. Let us imagine I want to create a point at 5, 12, 0 as the coordinate. 5 will be the X value, 12 will be the Y coordinate, and Z will be 0. So I need to give these three numbers as the input for X, Y, Z. To create a number, I'm going to use something called as number slider. Double click on the canvas. You get a dialog box. Type the number you want. So let's say I'm going to create the number 5. Press enter. I get a number slider like this. I'll repeat again. For Y coordinate, I want the number 12. Double click on the canvas. Type the number 12. Press enter. You get a number slider here. Again, I want 0. Double click. Type the number 0. Press enter. You get a number slider. So I have three different numbers. I want this number to be the X coordinate. What I'm going to do is drag and make a Y connection. As soon as I do that, just move your mouse on top of X coordinate. It will say one value inherited from one source, which is 5. If I connect 12 to Y coordinate by dragging and creating this wire, it will say that now the value inherited is 12. And I'm going to repeat that for Z as well. So what I'm doing is I'm creating a component. I'm creating some inputs for it. I'm dragging and making a wire connection. So the input is specified. When you specify the inputs, automatically component will process and give me the point as an output. It will say 5, 12, 0. When you move your mouse, you get to see that. If I minimize it, I see this point in RHINO as well. So if I minimize and have Grasshopper on one side and take a look into my RHINO screen, you can see I have a point coordinate that is 5, 12, 0. So there's an X marked here. And when I select the component construct point, the point is being highlighted here. And if I change the coordinate values, you can see the position of the point is also getting updated. So in the number slider, you will always have a slider through which you can change the numbers like this. So whenever I do that, automatically the position of the point is going to get changed. This is the basic idea of how Grasshopper and RHINO work hand in hand. Grasshopper interface is very different from the softwares we have worked with before. So if this is the first time you're using RHINO or Grasshopper, just pay attention, grasp the concept of it. See if you can try to do it. If not, also it's fine. You can just understand these whole new concepts and try it out later after class today. And to do any action in Grasshopper, you create components. Construct point helps me to construct a point. To construct the points, I will give the inputs as to what number should act as the X, Y, and Z coordinate. Once I do that, I will get the point output. In Grasshopper, you don't see the point. To see the point, you need to have RHINO on site. So whatever geometry you're creating, you see the preview of it on site in RHINO, something like this one. And that's it. So this is the basic idea of Grasshopper. Now, you can create more and more components to create more complex designs. So whenever you search for something parametric, when I go to Google and search for like parametric pavilions or parametric examples, you see something way more complex than, constructing a point. So basically what they do is you create a lot of components that is connected to one another in order to generate a more complex design or a more complex outcome. So that's the basic idea of Grasshopper. If I were to add on one more component here, let's say from this point, I want to create a circle. I'll use a component called a circle. Double click, type the name of the component. You will get a lot of options. Make sure you're choosing the correct one. I'm choosing the one that says defined by base, plane, and radius, which is creating a circle by giving the center and radius. So I'm going to select this. You want to specify by center, normal direction, or between 3 points. Like if you want to create circle in a different manner, you can select a different one. But for the basic one, I'm just choosing create a circle defined by base, plane, and radius. Base plane is the center. I want this point to act as center, so I'm connecting it here. For radius, even without specifying radius, you can see I have a really small circle. Also, to zoom in, you can just select a component, right click in Grasshopper and choose zoom. Helps you to zoom in a little bit, something like this. But you can see that there's a really small circle of radius 1. If you want to change that, just give a different number slider. If I give a number slider of 15 and connect it here, you can see radius is updating. Now I have the parameter of the radius. I have the parameter of the position of the center point by changing the X, Y, Z coordinates. So I can always change that at any given point of time. This is the idea of how the interface of Grasshopper works. We'll see how to use this interface to come up with an entire pattern on a surface and then next part of the session. Before that, I'm just going to run through the questions in the Zoom chat. Jim, I'm not getting line. Sarni, you need to create a line, but for now you can skip it. You can use the file that I have shared with you guys. Like if you are not done with the surface yet, it's fine. Just use the file I have shared with you and create whatever we're going to do next on top of it. Can anyone link to download Grasshopper software? You do not have to download Grasshopper if you are using RHINO 6 or 7. Just type it in the command. Okay, I think it's answered. Yeah. Input entered in Grasshopper not showing up on RHINO workspace. You do not see any inputs in RHINO's interface. So basically how RHINO and Grasshopper works hand in hand is, Grasshopper is where you set parameters and create the algorithm. Algorithm is nothing but multiple components connected to give an output. You call that as an algorithm. So Grasshopper is the interface where you create this algorithm. The output preview, you see it in RHINO, because RHINO is a modeling software. It is used only for seeing the preview. You cannot select it, you cannot edit it, you cannot do anything in RHINO. It's only to see the preview. All the things relevant to how the object or the design is generated will be through the components and parameters in Grasshopper. That's how they work hand in hand. Can you use bifocal plugin? I do not have the bifocal plugin, but I have my component names visible. So it solves the purpose. Like bifocal is if you're using short forms, I'm not doing that. I have the full form of the component name. So you can directly refer to that. In the center of the component name is visible. So construct point, circle, anything else I might use later. I'll be, that will also be seen. Okay, can you repeat the second step of circle? Use the component circle. Make sure it is the one that is defined by base, plane, and radius. So you type circle, choose this one. And plane, I'm giving the point as the center point. Radius, I'm giving a number slider. Grasshopper, that's the advantage. If you see my screen, you can just copy paste it and you will get the result. Can you suggest any book for the programming part? I would suggest a book called as Algorithmic Aided Design. It's a book I have personally read during my initial phase of Grasshopper, but I'm not sure if it is going to be suitable for someone who is absolutely like, starting off with Grasshopper. The book can help you if you have a basic idea of how Grasshopper works. And then you you have an idea of algorithms, you have like a little bit of experience and you just want to improve your skill, then it's a great book. Why do I have upper limit in Grasshopper and not a bigger number? You can change that. Just double click on the gray portion of the number slider. Just double click where you see my mouse. Takes you to this editor. You can change the upper limit in minimum and maximum. Another way to edit is right click, choose edit, takes you to this editor. Specify a minimum and maximum for the number slider. There's no output on RHINO as I work on Grasshopper. Karan, maybe you can share your screen. I can tell you why there is no output. Okay. So we'll continue in 2 to 3 minutes.
Is the screen visible?
Yes. 2 reasons for that. One is your point is hidden. Guys, in general, you have a component that is in gray color. It means preview is off. Just select on the component. Click on the center scroll button of your mouse.
Yeah.
You need to select this icon with the blindfold. It will say disable preview. Sorry, yeah, it is disabled. I'm sorry. Select the one with ball head, which will say enable preview. Can you repeat again? Yeah. Okay, you can see the point now, right? Second, for the circle, you're using the wrong component. You need to select the circle option with an orange color icon.
Is this the one?
Yeah, that's where you give the center point in the input plane and radius as a number slider. Another thing in general, guys, when you're working in Grasshopper, please work with full forms if this is the first time you're doing. Go to display in the
How do
menu
I
bar.
change that? Yeah, okay.
where I have annotated, go to display in the menu bar.
Yeah. in the-
Choose the option draw full names. Everyone, please make sure that the draw full names option is selected. So that way you have the
Thank you.
full forms of the component. You're welcome. And ma'am, can you please repeat surface making on RHINO after spiral? Guys, anyone who's not yet done with the surface, it's fine. Take the file that I have shared with you. And once the session ends, you can go through the recording to retry it. If we keep repeating it, then we won't be able to get all the topics that's planned for the session before 2 o'clock. Right, so just for now, you can use the file, and after the session, use the recording to go through it. Also, if you have any questions even after the workshop, feel free to WhatsApp us and let us know. We can help you out with that. At that point, didn't get XYZ values. That's because Sarani, the component name is construct point. Component name is wrong. It's not point, it's construct point. Repeat the book's name. I'll just type it out. It's called as Algorithmic Aided Design. It's a really good book, but as I said, if you're completely starting with Grasshopper for the first time, might be a little advanced. So just see how it helps. Grasshopper Pioneer, yes, it's a really good book and you can find it. It's basically like a user manual for Grasshopper, which can be found online. Okay, so let us see how we are going to create this entire pattern, which is this one, right? Yeah. So let's see how we are going to create this entire pattern on top of the surface. Okay. So I'm going to break down the logic first. Whenever you're working in Grasshopper, you learn two things. One is you learn the logic of how the algorithm works. Second, you learn how the components are put together in order to create the output. So I'm deleting this. This is just like a quick introduction to the interface, not part of the exercise or anything. So I'm just going to delete this. To create a pattern on this, first what I'm going to do is I'm going to import the surface to Grasshopper. Okay. To import a surface from RHINO to Grasshopper, I'm going to use this component called as surface. And guys, if you're using Grasshopper for the first time, please just take notes. Don't try to work along with me. It's going to be difficult to follow through. Like you will be learning and doing will be too much. So again, we do have like a 10 days workshop where we teach all of these softwares in detail. And the topic you're seeing right now is something we teach on day 5 of the session. And we are hardly 2 hours into the software. So it would definitely be too much for someone who's a beginner. Nothing to worry, just pay attention and make sure you have the idea and concept alone clear. So first I'm going to import the surface using a surface component. Choose the one that is in black color hexagon icon. This is the tool we are going to use for importing the surface to Grasshopper. To import it, what I'll do is I'll right click the component, choose the option set one surface. When I choose that and select the surface, it will automatically get imported. I'll repeat the import again. Using the surface component, right click, set one surface, select the surface, it gets imported. That's it. Now that I have the surface, next thing I'm going to do is I'm going to divide it into a grid. The pattern we have is very similar to this example you're seeing. So I'm going to divide a grid like panel on top of the surface. To do that, I'm using a plugin called as Lunchbox. I will show you the installation of Lunchbox in a while. If you haven't installed it yet, towards the end of the session, I'll run through the installation processes. But I'm going to be using a plugin called as Lunchbox, which will help me to divide this surface into some panels. So I can go to the components tab on top called as Lunchbox. On top of Grasshopper, you have different names like curve, surface, mesh. You call this as the components tab. Go to Lunchbox in that. You'll have something called as panels underneath that. And you will see a lot of different options. You'll see like diamonds, hexagons, quads, triangles, etc. Choose the kind of panel you want to work with. Let me just show you a few examples here. So I'm thinking like a triangle, a quad, and a diamond. Look at the inputs. Inputs are same. It will ask you what surface you want to use for creating the panels. It will ask how many number of panels you want in the U direction, that is along the length, and how many panels you want along the V direction or along the width. These are the only three things that is necessary for creating the panels, irrespective of whether it's diamond, triangle, quad, or something else that you're going to choose here. So feel free to select the panel of your preference. I am going to select quad panels for now. Okay, we can change it even after some time. For now, I'm just going to take quad panels. Also, when you're working, have this side-by-side interface where you see both RHINO and Grasshopper. Once I have this component, first input is the surface on which I want to create the panels. I want on this surface. When you make this wire connection, it goes as the input. A lot of components will have some predefined values as inputs. So UV divisions, that is the number of panels on the length and width, is already set to 10, which is why I'm getting this preview here. There's a small issue in how the panels are getting created. The issue is it is creating for the entire pipe. I have my surface limit only in the selected portion, but right now the panel is getting created throughout. So what I'm going to do is I'm going to modify the surface a little bit in RHINO itself. The surface will say it is a trimmed surface in the property. So if you look on the right hand side where my mouse is, it says it is a trim surface, which is why this problem is happening. So what I'm going to do is I need to rectify it. Whenever you're using Lunchbox, make sure it says only a surface. That's when you won't have this problem. You can rectify it in RHINO using this command called as shrink trimmed srf. Make a note of this command. You need to do this even on the file that I have shared with you. Use the command shrink trimmed srf. When you type that and press enter, the surface in properties will say only surface. It's no longer a trim surface. And once that is sorted, you can see the panels are created only within the limit of it. So what I have done is I have imported the surface, created panels using Lunchbox. Make sure the surface in property says surface and not a trim surface. You can rectify that using this command called as shrink trim srf you're seeing in the command list. That's it. And to hide unnecessary previews, you can say there are too many overlapping previews. Select the surface in RHINO and hide it. You can use a hide command for that. So you can just select and type the command hide, goes away. Second is you can also hide the overlapping previews in Grasshopper. So in Grasshopper also I have the surface and then the panels. You normally tend to hide the previous previews so that you don't have any issues or any kind of overlapping here. If you want to hide a component in Grasshopper, select the component, click on the center scroll button. It will pop up a lot of new tools. Choose the icon with the blindfold that will say disable preview. You want to enable a preview, again select it, center scroll, choose the bald head that says enable. These two are the tools that's going to both enable and disable the preview in Grasshopper components. If it is in RHINO, the command will be hide if you want to hide a RHINO object and show if you want to show the preview. Okay, so in RHINO, you can do for RHINO surfaces, RHINO curves, anything that you have created. For Grasshopper, you can do it for the components. Can you please teach about the installation of plugins so we can learn and along with you? Guys, as I said, I would suggest that you don't work along with me right away if you're someone who's new to the plugin. And for installation, how irrespective of crack or the trial version, it's the same. You need to download the plugins from the link that was sent by Akash yesterday. To install it, just double click on the installation file. It will ask you next, install, finish, like the basic installation things. You get this dialog box asking next, finish, install, like that. Just click through it. Installation will be complete. After the installation is complete, open RHINO and Grasshopper. Important thing is during installation, make sure RHINO and Grasshopper is not running in the background. The RHINO and Grasshopper has to be closed when you're installing. After installing, open RHINO and Grasshopper. Repeating the installation process. Link for installing shared by Akash yesterday. Download it. Double click on the installation file. It will say next, 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 finish, install, like that kind of basic setups. Once the installation is finished, open RHINO and Grasshopper, you will see Lunchbox on top, right? Let's maybe take 2 minutes, or let's say it's around 12:50. Let's maybe take till 1 o'clock for that, and then we will move ahead. I'm just going to pause the recording in the meantime. Let's take like 5 minutes for you to install it. Okay, so let's continuing with exercise. I hope you have Lunchbox installed. And we are going to try to recreate a pattern similar to this example. We are trying to recreate a prism-like module. Let me first run you through the logic of prism-like module, and then we will see how we can go about it in Grasshopper. So the steps we are going to do in order to create a prism is, let us say I have a rectangle. Okay, so rectangle is the panel here, or any base geometry on which you want a prism. This is just an illustration for you to understand the steps. We will be doing the same thing in Grasshopper on the panels. So first, you take the panel. To create a prism, you will find the center of the object. Once you find the center of the object, you will move the center point to get the tip of the prism. After you do that, we will use a command called as extrude curve to point, that is a component if in Grasshopper, and specify the curve and snap at this point to get a prism. That's it. So these are the steps involved in creating the module. I repeat again, we have the panel, find the center of it. After finding the center, we move the center point, and then we create the surface using that. That's it. So 3 steps: find center, move center, create the surface. Now let's try to do the same thing in Grasshopper and all of these panels. First, I'm going to modify the panels a little. I feel like it is breaking down my organic surface a lot. Like my surface is not at all smooth. You can just increase the number of panel divisions. Default is 10 by 10. I'm going to increase it to maybe, let's say 25 along the U, and maybe a 20 along the V direction, something like this. Okay, so when I increase the number of UV divisions, you can see that the smoothness of the surface is retained so much better in here. Once we have the panels exactly how we want, the first thing I'm going to do is to find the center of the panels. So when you're doing any action in Grasshopper, it is through component. So finding the center, moving it, everything is done through components. To find the center, I'm going to use a component called as area. Make a note of this. Area component will help you to find the center of an object. It will ask me for which geometry I need to find the area. I want to find it for all the panels here. So I'm going to connect it to it. And as soon as I do that, take a look. You can see the center of each panel is now highlighted. So I'm using the area component to do the first step, which is to find the center of the panels here. Next step is to move the points in the perpendicular direction so that I can get the prism's tip, or the position of where the tip of the prism has to be. So if I want to move an object, I'm going to use a component called as move. Just type move and select the one that says move. When you want to move an object, it will ask you for 2 things. First is the geometry or the object you want to move. Second, motion is nothing but the direction in which you want to move. These are the 2 things it will ask me. The geometry I want to move is the center. So I'll just connect the centroid. as the geometry I want to move. It's coming from the area component. I'm connecting it as the geometry I want to move. Motion, just like a lot of components, it has a default motion which is along the z-axis. You can see the points are moving along the z-axis here. I don't want to move it in the z-axis. What I want to do is, I want the points to move in the perpendicular direction. So I want each point to move along the perpendicular direction of that specific panel. So this direction is called as normal. To specify a normal direction, I need to find it using evaluate surface. I'm repeating again, move for motion default is z-axis. I don't want to move in the z-axis. Instead, I want to move it in the perpendicular direction of each panel that is created here. So to do that, I'm going to find the normal direction of the surfaces. To find the normal, I'm using the component called as evaluate surface. It will ask me for which surface I need to find the normal direction. I will give these panels. Second, it will ask me at which point I need to find the normal direction. Don't connect the centroid. There is a small detail part there that you need to understand. Centroid is an XYZ coordinate. Evaluate surface will ask me something called as a UV coordinate. UV coordinate is a different kind of a coordinate system that is used for each surface. So U and V is nothing but the length and width of a surface. So you need to specify the position along the length and width of the surface where you want to analyze. Simple solution, don't get too confused about that. Just use a component called as MD slider. This is called as MD slider. Once again, let me show you. Component is called as MD slider. This one. It will look like a box, something similar to just disconnect it as a point. Sometimes your preview can get a little messy. That's all right. Just hide the preview of the component. Like sometimes when you do this component, your preview might end up looking something like how you're seeing in my screen, or even bigger than that. Let's give 35. You might end up looking something like this. That's absolutely fine. That's how this component's preview will be. You can just hide it off to avoid confusion. Now take a look at the outputs. One of it says normal. Okay, so it's saying normal is one of the directions that has been found by analyzing the surface. You can directly give it into the motion. Right now it's moving in z-axis. I have found the normal direction of all of these panels that is coming as an output here. You can just drag and connect it to the motion, which is the direction of moving. Now take a look. All the points move along the normal direction. There's a small disadvantage here. Any idea what that is? I'm moving the points to find the tip of the prism. I'm moving along the normal direction, which is perfect for me. But there is one more thing I would want to do here. Any idea what that parameter is that I want to control when I'm moving the points? Exactly. I'll want to control the distance as well. Right now, I'm controlling the direction normal. I have no control over how much distance it is moving along the normal. So what I'm going to do is I'm going to use a new component called as amplitude, which will help me to add a length to a vector. In the sense, normal is the direction. I want a distance value attached to the direction. Amplitude is going to help me specify that. You specify the direction as the vector input. So the normal is the direction I'm putting in as the vector input. Amplitude is where I specify the distance or the length that has to get attached to the direction. Let's try a random number of maybe 1.5 and then connect it here. After doing that, this vector has both the direction normal and the distance 1.5. So what I'm going to do is, instead of connecting the normal directly, I'm connecting it through the amplitude component so that I can control the amount of distance it is moving. So now if I select the moved component and then change the number slider, you can see that the points distance is also something I can control. Once I have the tip of the prism, all I now need to do is create a surface there. I want to create a surface between the base curve and the tip of the prism. To do that in Grasshopper, I'm using a new component called as extrude point. It will ask me for two things. What is the base geometry of the prism? Base geometry is the panels that I have created. So I'll just connect it here. Then it will ask me what is the tip of the prism. The moved point is the tip of the prism. So I connect it here. As soon as I do that, I'll have the prisms. That's it. And always for a better preview, hide all the previous steps or all the previous components in the algorithm. Just have a preview of the final component and then you will be able to see the result. I'll repeat the steps once again. Let's run through the algorithm again. So first step is you create any surface in RHINO. Doesn't have to necessarily be this one. You can create any surface in RHINO. And then you can apply some kind of paneling system to it. So first step is to create panels. Use Lunchbox, go to panels, create a panel of your preference. I'm selecting quad panels here. When you're giving panels, increase the UV divisions. That way you will get a smoother result. If you have less numbers in the UV division, so if I reduce this number slider and reduce the divisions here, you can see the object will be very broken down. So always have a higher number of UV divisions when you're using the Lunchbox panels. Once you have created the panel, first step, find the center of each panel. To find center, we use the area component. Second step, we move the center points that we have just found. To move the center points, we move along the normal direction. So I'm using an evaluate surface component, which gives me the normal direction. And I'm also using an amplitude component that helps me control the distance of moving. Once I have moved the points, I just need to create a prism between the point I have moved and the base panels that is there. To do that, I'm using the component called as extrude point. So once again, the steps are create surface, create panels, find the center, move it in the normal direction, and create the prism. That's it. So these are the different steps in the algorithm. Now there are a few parameters we can change here. First parameter is you can change the number of panels, which we just did a few moments ago. Second is you can change the distance after it's done. So the prism's height is controlled by this number slider 3.7. I can increase or reduce it at any given point of time to get a different result, something like this. And another interesting parameter I can change is, let's say I'm not happy with the result. I feel like I could have used a different kind of paneling system instead of quads. You can always go to panels, choose a different kind of paneling system at any given point of time. Specify the surface again. When you give that, let's hide the preview of the final output so that we see the panels a little better. Specify the surface you want to create the panels. Give the number of U and V divisions so it gets smoother. I think a V division can be a little bit higher in this example. Maybe let's try 25, a different number slider. And once you're happy with the paneling division, just apply this entire algorithm to triangle panels. So don't use quad panels anymore. Instead of that, you can just plug it in, all the wire connections from here, you can plug it into the triangle panels. To do this kind of removing and replugging, hold down to Shift and Control in your keyboard. It will help you to remove it and then drag and connect it. I'm holding down to Shift Control and then I'm clicking and dragging. It will automatically connect to the new component. Now what I can do is switch on the final preview to see how the prism looks like. You can see I have it on the triangle panels. That's it. So this is pretty much how you go about creating this prism-like modules that you saw in the pavilion. And the best part is you can create copies of this algorithm on different surfaces. So if I show all the hidden surfaces in RHINO, we created few surfaces through Loft. I'm just going to unhide everything by using the show command. I'll have a lot more surfaces here. Let's say I want to try the same thing on this surface as well. Let's do one thing. Let's create a copy of this entire algorithm. Just press Ctrl C in your keyboard by selecting the components, which will copy it, and then Ctrl V in your keyboard, which will paste it. You can see there's a copy now. Just move it aside. And after moving it aside, remember the first component is where we import the surface. We just need to change that. Right click, choose set on surface, and then select this new surface in RHINO. It will get applied to this one. When you apply to a new surface, make sure the UV divisions match accordingly. So let's hide the prism. Let's give UV divisions that's more suitable for this surface. I'm just going to increase and see how this works. Okay, this is too much here. Let's reduce the U divisions and let's increase the V divisions much higher. You just need to, reduce and increase and see how much division works best for the curvature of the surface you're having. I think somewhere like 8 or 10 should be good in this direction. And once, I have done this, switch on the final preview output for the prism. I'll have something like this. There's a small issue here. The prism is getting extruded inwards. I want it to come outwards. So when you want to change the direction from outside to inside or vice versa, wherever you're doing the movement of the points, just add a negative to it. So instead of giving a positive number, connect it to a negative component where the number becomes minus 3.9. Just look at the output. Instead of 3.9 becomes minus 3.9 and then connect it to the amplitude. Also, I think the extrusion height is too much. Let's try a 0.5, something smaller. It is way more suitable for this example. So you can see that, it's just the same algorithm. I copy paste it, change the surface, change the parameter of number of UV divisions, that is the number of panels in the UV direction. And also I'm changing the parameter of the distance on how much the prism has to get extruded. And I automatically get a different result. And for a better preview, when you look at this, the preview looks very weird. Like especially if I were to change it to the rendered mode, it's not going to look that good. So what you can do is you can add something called as custom preview to the final output. It will ask you what is the geometry you want to have a better preview. It's the final extrusion. I'm just going to connect it here. And for material, by default, it will have a pink color. So when I put it to shade it will have this pink color as a default material. You can change it using a component called as color swatch. Connect this to the material, change it to a different color. You can click on this color and change a different one in here. Hit accept. And then now if I go to render mode, again, preferably hide the previous components to avoid any kind of overlap in the previous. Just hide everything. I'll have something that looks like this. A few more things that you can do to make your previews look even better is hide everything else in RHINO. Add a ground plane to it. You can add a ground plane by using this rectangle plane tool. You can use this command called as plane in the command box and create a huge ground plane like this. Once you have the ground plane and you switch to the rendered mode, looks so much better. If you want, you can even add some sunlight to it using the command sun. So just type sun in the RHINO's viewport. You get this dialog box. Switch on the sun, switch on the manual control, specify where you want the sun to be positioned. And if you feel the intensity of the sun is too much, you can reduce it in the intensity. I'm going to give 0.5 and just play with the sun and see how or which position works best for your object. And that's it. Once you're done, you can take another quick turntable and see how the final outcome is looking like. So try this out. I will leave the grasshopper screen open for you guys right now. It's 1:18. Let's take till 1:30. You can run through your questions if you have any. Those who don't have any questions, you can do a quick attempt at how to go about it. All right. Also, another interesting command that I think you will find helpful is you can just navigate and position your screen, how the render looks best for you. And if you want to export this as a high quality JPEG image, you can do that in RHINO using this command called as -view capture to file. Look into the command box for the spelling. You first add a hyphen and then type the command hyphen view capture to file. In the dialog box, you specify the width and height in the HD resolution. Width, let's give 1920. Height, I'm just clicking on it and giving 1080. After you change the width and height, just choose browse in the command box, and then it will open up this browser. You need to specify where you want to save this. So I'm just going to save it in desktop under the name, let's say Prism Pavilion, and then hit save. Once it is saved, your command box will say image is successfully saved in the location that you have specified. And if I go to desktop and open the image, I'll have a high resolution image of whatever we just used using the hyphen view capture to file. So whatever you see in the viewport that you're using, it will be exported as a high quality JPEG image. That's it. If you want an even better render preview, I would recommend using the ray trace mode. The render mode is like a quick clay-like render. Ray trace is like the proper render, looks a little bit more realistic in terms of the sun, the shadows and everything. See what you like better. And then you can, wait for a bit. This will say it is actually rendering right now. You can see in the bottom of my screen, I get indications of how it is rendering and how many passes are completed. So just wait until all the passes are completed. And then you can do a hyphen view capture to file. It will take a little bit longer for rendered images, like it will process the render. So it will take a little bit more longer for the image to get exported, but you will probably end up with a more realistic output than just a rendered mode, which gives a quick clay-like render. See what you like best to come up with the final outcome. As I said, I'll just leave the algorithm open for you guys to try out. You have the component names also clearly visible. Any questions? I'll just run through it right now. By 1:30, we will move on to an example where we create a form. So right now, surface is done in RHINO. We are going to see an example where the entire surface itself is created in Grasshopper, analyzed for the amount of radiation, and then the surface is, optimized to make sure you get minimum amount of radiation. So we're going to see a quick workflow. It will definitely take another 30 minutes. So by 1:30, we'll continue with that. Guys, you cannot record the video from your end due to the privacy issues, but we will be sharing the recordings with you. And don't worry about not being able to follow through at the same pace of the session. As I told you guys, this is something we teach on our 5th day of our 10 days workshop, where we look into RHINO Grasshopper software is much more in detail. So that is the level of learning you're just trying to attempt in a few hours. So see it as a session where you get more insight on what are all the different possibilities when you apply parametric strategies in design, and see how much you can attempt out of it. So the pace, do not worry about that. Can we find these preset algorithm online? I will share this file with you when I share the recording of today. I will share the algorithm and all of the files we have used in class. So it's helpful for you guys to go through. My example is with, yeah, is someone about to ask a question by unmuting themselves? Okay. My example is with all the dots and planes in reds, nothing like the one there. I wonder why that is. If you don't mind, you can just share your screen. I'll take a look into what is the issue. Also, guys, maybe you can take a quick screenshot of it. So if in case someone is sharing the screen, you don't want to miss out on it. So maybe you can just take a quick screenshot of what you're seeing in my screen, and you can even share it in the Zoom chat if you want to use it for now. I'll just leave it on for a few seconds. Once I stop sharing my screen, Rui Santos, you can
see it already or not?
Just a minute.
Okay.
I'll just stop sharing. Yeah, I can see your screen.
Very good. So this is happening over there. Everything is red. I don't know what did I wrong?
Can you just show me your grasshopper algorithm, like
Sure.
maximize it so I can see the entire set of components used? I don't mind if I don't see Rhino, that's fine. Just the grasshopper preview is enough. Your algorithm looks perfect. There's nothing wrong with it. Just that you have preview of all the components involved in the algorithm. So select all of the components, hide the preview. Just the final preview alone, let it be on.
It's just the final one.
Yeah, just the final one.
So it should be something like this.
Yeah, the selected one should be hidden.
Preview, okay.
And now if you minimize and see, I think you should not have an issue. Also, when you select and right click, it's going to hide the preview of only a single component.
Okay.
So you need to use the center scroll.
Something like this, closer.
Yeah. I think you also have the preview of the surface done in Rhino. So you need to select that in Rhino and hide it using the hide command in Rhino.
Hide. This one, hide.
Yeah.
Okay. So yes, it's done now. Thank you very much.
Welcome. And question, could you help in installing of the plugins? Yeah, sure. If you have an issue or a trouble installing Lunchbox, just let me know. I can help you with that as well. Is there any trouble you're specifically facing, Sarani? In case they're saying something, your mic is still on mute. I can't hear you. After modeling a form, how will you work on the interiors? I'll just open some of my files that I work. Just give me a minute. Sarani, to answer your question, if you have installed it and it's not showing, close RHINO GRASSHOPPER entirely, reload a new file. So if I were to share my entire screen, you need to close RHINO GRASSHOPPER, open a new one by right clicking here and choose Rhino 7. It should not be like file new document. It will not work. Has to be completely closed and a completely fresh Rhino document. You should find it there. If you still don't find it, let me know. And to answer the question regarding the interior, this is actually an interior project that I am currently working on. And the entire model is done in Rhino. And again, for the interiors. So basically what I do is, this is the file. I work everything in Rhino actually. Even for my drafting, if you just look at my entire screen, you will see that the only softwares I work with is RHINO GRASSHOPPER and Photoshop for post-production. Apart from that, I don't really use anything else. Everything is done in RHINO itself. So once I draft, like, what's the plan, detail, everything, I create the basic outer model. And once I have the basic outer model, I have them as different elements, like a roof is separate. Let me unlock the layers as well. Right. So I have them as different layers like roof, the wall slabs, the floor slab and everything. I just hide them and unhide them so I can zoom inside a model, work on the interior. So if I'm working here, I'll probably hide these roofs using the hide command, work on the detail of it, and then I will show it back. So it's basically isolating different parts of your model and then working on the details of it and then showing everything else together and having it in the same place. That's the overall idea or concept of how I do the interiors. Let me know if this answered your question, Shahidullah, or if you have something else in mind for this. And again, guys, the session is not over. We'll continue in a minute. I'll just answer one more question from Kamini and then I'll continue. Meantime, Shahidullah, just let me know if your query is clear. And also there was a question earlier, how do you import components? These sofas and everything you're seeing is a SketchUp warehouse component that I import in Grasshopper, so I can use it for take renders. How can we export a high quality render from our model? The render that I showed you, which is this one, I have taken it using V-Ray. So I have V-Ray installed along with RHINO. RHINO is good for everything except renders. You can do drafting as good as AutoCAD, modeling much better than any other software. But when it comes to render, it's the absolute opposite, gives you pathetic renders. So I would suggest you to have it with any other render engines like Lumion, Enscape, V-Ray, whichever you're comfortable with, and then take a render out of it. I personally prefer V-Ray because it's much more realistic than anything else. And is there an eye or a camera tool I can sketch on? Yes. So you have the camera positions on the side. Go to the properties. The camera lens length is the field of view. So let me just show everything. And let's say I zoom in to take a render. You can see that, my preview is very limited, like the field of view is very limited. Lens length, same as field of view. Smaller lens length will give a higher field of view. And I prefer to work with 2-point perspective when I'm taking renders. So go to projection, set it to 2-point perspective. And Z location is the eye level. So if your model is perfectly to scale, it will represent the eye level. I think I've worked in the unit millimeters for this one. So I need to make sure my eye level is 5 feet, means I think around 1,500. I'm not sure exactly of the conversion. I'm just approximately doing it now. And the Z location will represent the eye level of my camera. Once your scene is set, save this using the command name view. You need to choose save as, give a name to it, let's say test, and hit OK. Scene is set. So every time you want to go to a different scene, just click on it, choose restore to current viewport, and again restore to current viewport, reverts it to that scene. Command name to set a scene is called as name view. Twinmotion is sort of, I think it's a personal preference. Each person prefers a different software to work with. I prefer V-Ray. Probably because I just got used to it. So yeah, it's up to you. Even Twinmotion works perfectly fine with RHINO. What was the name of component you connected to point thing of evaluate surface? It's called as MD slider. I'm assuming you're asking the box-like component. And what is the difference between Dynamo and Grasshopper? Difference is one, Dynamo is the same as Grasshopper, but for Revit, but it's fairly new, like because Grasshopper is, starting to become really powerful when compared to like Revit modeling. So they wanted to incorporate a parametric engine as well, which is why Dynamo was introduced. But it's fairly new. which means the resources available for Dynamo is very limited. Grasshopper has thousands of plugins, whereas Dynamo will hardly have hundreds of plugins. So the resources that you have to come up with any kind of models, I would say Grasshopper is much more superior. So, I mean, I personally prefer that. All right, so let's continue with the session. We have, I think we might go a little bit overboard on time, probably 10 or 15 minutes. I'll try to restrict within the time limit. Let me open up the file that we are planning to do next. Save changes, no? Okay, let me just open a new document. Normally, when you choose new document, you get to set a unit. Go for large objects when it comes to architectural or interior models. Small object is for people who do designs like on a smaller scale, like jewelry design, or you have like smaller industrial design projects like a faucet or a spoon. You can go ahead with that. Okay, so I hope you guys can see my new Grasshopper file. The remaining questions, I'll just come to it. I think I have yet to answer Kamini's question also. I'll come to that as well towards the end on how do we export the objects. And I'm going to open up Grasshopper. Let me show you what we are going to do next. It's a workflow where we create an object, analyze it for radiation, and then optimize the form. So this is a workflow we are seeing. Let me open the file for that. Okay, so we are going to see workflow where we create a form in Grasshopper. So what I'm first doing is I'm just creating a box, twisting it like a skyscraper tower. And once we have done that, next part of the workflow, what I do is I run it through radiation analysis to calculate the amount of radiation that hits on the surface of the tower that I have done. And third thing that I'm doing in the workflow is radiation factor will change whenever I change the angle of twisting the tower. So I'm going to use a generative design tool. So I'm just using a Galapagos tool, which will tell me which angle of twisting is the most optimum if I'm trying to have the least amount of radiation. So these are the three parts to the workflow. Part one, we design a form. Part two, we analyze the radiation. Part three, we optimize the form based on the analysis we have made in radiation. So these are the three things we are doing. I will share this algorithm with you. Just pay attention to the workflow. You can try it out after today's session. So let me do one thing. Let me delete what we have done. And let me also disable this component, disable the inputs that we have. We'll try from scratch. So first, I'm going to create a twisted box. I can do that in RHINO, but I'm doing it in Grasshopper because the things that you can do in a modeling software, when you do in Grasshopper, you have possibility of making it more optimized and the best outcome. So for creating a twisted box, step one, I'm creating the plan. Plan is nothing but a simple rectangle. So I'm using a component called as rectangle, which is this one. It will ask me for the X and Y size, that is the length and width. Let's just give 15 by 15 as the length and width. I automatically have something like this. You can give a fillet radius to it if you want. It's set to 0. I'm just going to increase it to 1 in here. Maybe a little bit higher, maybe 1.5. And that's it. So I'm done with the basic plan of the tower. outline of it. Next, what I want to do is I want to extrude it into a box. Right now it's a 2D curve. I want to extrude it into a box. I'm using a component called as extrude, which is going to help me do that. It will ask me what is the base geometry I want to extrude. Again, a few easy things to do to understand the software is observe everything. In the sense, when you hover your mouse, it will always tell you what is the input description, the component name description, output description. It will help you a little bit better as a beginner to understand what's happening. So it will ask me for the base to extrude. I want to extrude the rectangle I connected here. Then it will ask me in which direction I want to extrude it. I want the rectangle to extrude in Z axis for it to become a box. To specify a direction along Z axis, I'm using a component called as unit Z. In the previous exercise, we specified a direction along normal. For that, we did few steps using evaluate surface. In this case, for Z axis, it's very simple. You have a direct component. You can just connect the output here as direction. Now, when you give unit Z, the distance of extrusion, you give it in the factor. Factor is the number or the numerical value that gets attached to a direction or a vector. So you need to specify the distance of extrusion in the factor. Default is set to 1. I'm getting like this. I'm going to increase it. Let's give 65 and see how it looks proportionately to this one. It looks fine. It looks like a proper tower. Maybe a little less. It's up to you. And once I have the box, next what I'm going to do is I'm going to twist it. To twist it, I'm using the component twist. It will ask me what is the geometry I want to twist. I want to twist the extrusion. I connect it here. Then it will ask me in which axis I need to twist. When you're twisting, you ideally specify a central axis on how much twist should happen. So if I want to twist this box, the pink colored line annotation that I have made is the central axis I will be using for twisting. I need to create this line in Grasshopper. Only then I can specify it as an axis. To create such a line, again, it's a new action, so I'm using a new component for that. There will be a few options for creating lines. I will choose the one that says line SDL. Look at the description. You create a line segment by defining the starting point. Tangent is the direction of the line and the length of the line segment. So I'm going to use line SDL. Starting point of this line. Guys, I want you guys to guess and tell me what would be the inputs. It's very simple inputs here. What should be the starting point of the line segment if I want to create something similar to the pink color annotation? Just logically, what do you think should be the starting point? It should be the rectangle. Exactly, it should be the geometric center of the base rectangle. You cannot give the rectangle directly. It will look at the description. It is asking line start point. It's asking for a point where the line has to start. The line has to start at the center of the first rectangle we created. So I'm going to use the area component that we saw in the previous exercise. Helps you find the center. I want to find center of this rectangle, so I'm connecting it here. Now look at the centroid. You can see the X being highlighted at the center. Let's give it as the start of the line. Now, what should be the direction here? It's going to be the Z-axis. So for Z-axis, I'm going to use the same component as before, which is unit Z. I connect it here. It is asking me for the length of the line separately. And if I want the axis to be the same height as the extrusion, which is 63, I'll give the same slider as the length. Okay. Let me remove the annotation. I can give a different number slider. Like if I give 25, the length of the line is 25 units. Again, I give 79. Length of the line is 79 units. It's up to me. I want the length of the line same as the height of extrusion. So the number slider specified for height, I'm using the same here, right? That's why it's the same number slider. Once I have this line, I'm going to use it as the axis. Next, angle has a default value. Also have the habit of hiding the previous steps. If you don't do it, it will be very confusing. So make sure hide the previous steps. Next is the angle. Whenever you specify angle in Grasshopper, first thing you do is change the units of it. Angle is always considered in radians. I will be using the degrees when I specify an angle. So I'm going to right click, switch it to degrees. And angle, I want it anywhere between, let's say, 90 degrees to 360 degrees. I will just create a number slider by typing 90 ... 360. So instead of giving the number for the slider, I'm giving the lower and the upper limit. So I'm giving minimum 90, maximum 360 using this format, 90 ... 360. Enter, connect it here. Twist happens for 90 degrees. I can just play around with this value and see how much twist I want. Let's just give a random number for now. That's it. So this is how I went about creating the basic form. Quickly running through the steps. Create the base rectangle, extrude it in the z-axis, twist it. When you're twisting, you might have to specify a line segment to give it as the axis. So I'm creating that as well as an input for twisting. That's it. Once all of this is done, next step of the workflow is to analyze it for the amount of radiation. To analyze it for the radiation, I'm using a plugin called as Ladybug. I will teach you the installation of it after this exercise, because either ways you cannot work on it by yourself. You need an example file every time you're using Ladybug. So that's the best part about Grasshopper plugins. Anytime you install a new plugin, and if you go online, whoever has created the plugin will make sure there are some resources that is going to help the user understand how to work with the plugin. And the resources will include either an example file, or it will be a manual that explains all the components in the plugin and how to use it. In Ladybug, you have both. You have a primer for Ladybug, how it works. You also have a bunch of example files that is released by the creator. I'll share the link of the official website where you can find both of the resources in the WhatsApp group at the end of today's session. So what I have done is, I'm using the plugin Ladybug. Ladybug is specifically used for environmental analysis. And in this example, I am doing the radiation analysis for the building. So I went to that online resource place, downloaded the radiation analysis file. You just need to change 3 to 4 inputs in the algorithm. Like, what is the north direction of your building? What is the building you want to analyze? What are the surrounding context? And in which city your building is located for the weather data. When you change these basic parameters, automatically analysis will happen for your specified geometry. So I'll show you what are the basic parameters you need to change in this algorithm. This is the algorithm. I'll be sharing it with you guys. Make sure the parameters I'm changing, you take a note of it and you apply it for your algorithm. Doesn't have to be just for this building example, can be any model you have done in SketchUp or Revit or any software. You can import and run an analysis here. Step 1, disable the main component. It's a very, very heavy plugin. So I would recommend that you disable the main component before you start the analysis so that your system doesn't lag a lot when you give the inputs. First is the north direction of the building. North direction of the building, I'm going to import a vector from RHINO. Use a vector component for that. So this is the one annotated in black hexagon. Just right click and choose set one vector. Takes you to RHINO's interface. Give which is the north direction. So if you have a specific angle, you can snap at that specific line. You will most likely have a line that is indicating north direction. You can snap there. I'm just going to give along the y-axis here. So I'm holding down to shift, snapping along y. It's up to you. You can give a different vector also. Connecting this into north. I repeat again, right click, set one vector, click the direction of north in RHINO, gets imported, connected to north. Next is the geometry I want to analyze for the radiation, which is this twisted output. So I'm just going to drag and connect it here as the geometry. Context is any geometry in the surrounding that will affect the amount of radiation. So if I have any surrounding buildings, any surrounding trees, any object which will affect the amount of radiation that hits on the surface goes as context. I'm going to create some hypothetical boxes here, but you can feel free to have a real-time context, like you can download the city map online and you can import it to RHINO and have the height extrusions as the actual context, or you can just have some examples like how I'm doing right now. It's up to you. I'm just going to use the box tool. Just type box in the command box, and I'm just creating some random boxes that looks like the context tool. All right, looks like I have some surrounding buildings. So let's just put it to shade it. Looks like it's in a cityscape. Now what I'm going to do is I'm going to import all of these boxes that I have done as the surrounding context. I'm going to use a geometry component for that. Again, the one annotated in black hexagon. Anytime you want to import something, it's always right click, choose set one geometry. This time I have multiple geometries. I have like 5 to 6 boxes. So I'm going to choose set multiple geometries instead. Selecting all boxes, pressing enter, gets imported here. This one goes into the context. Okay, so not giving the north direction of the building. Geometry is the building I want to analyze for radiation. Context is the surrounding boxes that affects the amount of radiation on my tower. Grid size is when you do the analysis, technically your surface gets divided into smaller grids. You don't get the surface entirely in a single color if you noticed. The surface was divided into smaller grids. For now, I'll give a number. When we get the result, I'll explain it a little bit more in detail. So for now, I'm just going to give a number 1.5 and connect it as a grid size here. Once this is done, the next input I want you to change, which is one of the most important input, is a file called as EPW file. EPW file is a short form of energy plus weather data. It's a compilation of the weather data for each city across the world. So what you need to do is wherever your geometry or building is located, you need to download the EPW file of the relevant city, and then you need to import it in this algorithm so that weather data is getting applied while the analysis happens. The process is simple. Let me just delete this. Open weather file is where you open the EPW file. So make sure you have that file downloaded from online. I'll share the resource for the same. I'm using the file for the city Chennai in India. You can download for a different city where the building is located. I'm using a component called as Boolean toggle. What will happen in this component is if you double click on the false, it will change to true. If you double click on the true, it will change back to false. So every time you double click, toggles between true and false text here. Now, what I'm going to do is I'm going to have it at false and connect it in open or as the input open. After connecting, when I try to change it to true, look at what happens when I double click. Automatically takes me to my browser or my computer, and it is asking me to specifically select an EPW file. I'm going to go to the location where I have the EPW file and I'll select that one. Similarly, you need to have downloaded for your city. Just select this file as soon as you open this document. And wait a few seconds. It is trying to process that EPW file, so system will not respond for a bit. This is also the reason why I ask you to disable the main component as soon as you open the algorithm, because it will take time every time you change this input. So now EPW file is also set. Last one is optional. You have something called as analysis period in the algorithm. You can specify a duration you want to analyze for the amount of radiation. If you don't specify this, like if I delete this part itself, it will analyze for 365 days a year. I prefer analysis period where you can specify from which month, which day, which hour, till which month, which day, which hour you want to conduct the analysis. Month, look at the description. It will tell you to give a number between 1 to 12, where 1 is January, 2 is February, until 12, which is December. I have given 4 because I am analyzing from April. Day is anywhere between 1 to 31. So you specify from which day the analysis has to start. Hour is a 24-hour format. So make sure that you give the numbers accordingly. 11 representing 11 a.m. 16 representing 4 p.m. Same way, 2 month, to which day and till which hour. To read this data out, I'm analyzing from the 1st of April till the 15th of June, which is like the peak summer time in the city I'm analyzing. And the duration of analysis is from 11 a.m. in the morning till 4 p.m. in the evening, which is again when the sun is at its maximum peak. Once you specify this, you can change it according to your requirement. Once all of this is done, that is setting the north direction, building and context to analyze grid size, also the duration, and most importantly, EPW file. Once you change these 5 to 6 things, select the main component, click on the center scroll and choose enable. So the component will start to process the data. Once it is done, hide any other preview except this radiation analysis component. You can see I have a result that looks something like this. And to read through the result, as you can see, the surface is divided into smaller grids. I have given size 1.5, so it has divided according to that. A smaller grid size would be even more accurate. And each grid that gets divided is analyzed for the amount of radiation. Hotter regions receive a radiation color red, colder regions receive a radiation color blue. So if you were to read through this document, you have a legend system that represents what each color code radiation value is. And also it says the unit is kilowatt hour per meter square. That's it. That is pretty much how you go about carrying out a radiation analysis. And finally, the total amount of radiation result, you will find it as an outputted result. So what I'm creating right now is called as a panel. You can just double click and type something called as panel. If you connect an output, it will tell you what's the number coming out of it. So the total amount of radiation is 36,410 kilowatt hour per meter square. So that's the total amount of radiation that hits on this specific surface. Any questions until this? We just have one small part. The session will extend another 10-15 minutes. I hope it's okay for you guys. Yeah. Any questions by the way until this? Clear. Okay, so now that we are done with this, normally whenever I use a radiation result, I feel like radiation result is not like a final output at all. It is something that is going to help us along to make better decisions in our design. So if I analyze and find that my building is having X amount of radiation result, then I need to do something to make sure that my building receives lesser amount of radiation result. Like I need to do certain changes to my design to make sure I get lesser amount of radiation result. So what I'm going to do here is I'm going to change the angle that I twist. So if I were to bring the panel that has the radiation result close to the angle of twisting, every time I change the angle, so instead of 255, if I give 180 degrees, you will notice that the amount of radiation that hits on the surface is different. Instead of 180, if I give 120 degrees, the amount of radiation that hits on the surface is different. So every time I change the parameter of twisting, I get a different amount of radiation result. But for me, practically as a user, it is pretty impossible to change every single value in the number slider and find out which gives me the least amount of radiation. Like that is practically not something I can do in here. So what I'm going to do is, this is where I told you the difference between parametric and generative. Parametric is where I change the parameters to get an output. Generative is where the computer changes the parameters by itself to make sure that my final result is of its maximum efficiency, right? So this is the main difference between them. To do that, I'm introducing a new component called as Galapagos. That's one of the most powerful components in Grasshopper. It's a special component too. Looks very different from what we have seen till now. And also, guys, I'm just muting if it's a background noise. If you have a question for now, just type it out in the chat. So, yeah, so I'm going to use Galapagos. It will ask me for two things. Fitness is a number I'm trying to optimize. That is the final output that I'm trying to optimize is the fitness. Genome is the input parameters that I am trying to change to get the best output. I'll repeat again, fitness is the output I'm trying to optimize. I'm trying to optimize the amount of radiation result here. So that goes in as the fitness. Radiation result comes from this component. Galapagos, you can't connect like this. It's a little different. You drag from the component and then you snap it to the result or the number you want to optimize. Okay, so drag from fitness and snap to the output you're trying to optimize. Next is genome. Genomes are the parameters that I want Galapagos to change in order to find the best result through fitness. So the number slider or parameters I want to change is this angle of twisting. Again, it is not necessary that it has to be only one parameter. You can have multiple parameters. You can change parameters like the size of the plant, but I think ideally smaller the plant size, lesser the radiation. So the logic hit will happen. But you can have like multiple parameters if you have worked on a more complex algorithm and give it as the genome. So fitness is the output you want to optimize. Genome is the initial parameters. Once you have given these two, this is a personal preference. Just organize your screen a little so that you can see the RHINO on one side, Grasshopper on another side, where both the genome and the final fitness value is visible. And once this two is set, double click on Galapagos to run the optimization process. It does not give an output as such. Double click Galapagos, opens up this dialog box. Change the fitness settings here. Maximize or minimize is nothing but I have given a number to fitness, which is the radiation analysis. I need to tell Galapagos whether it should try to maximize the number given to fitness or minimize the number given to fitness. I want to minimize it because it's the radiation result. I want least amount of radiation, so I'm trying to minimize it. So just click on the minus, it goes to minimize. Runtime, choose enable. Duration of analysis, I'm just going to give 2 minutes for now. Again, it's going to be a very slow process because Ladybug is heavy. So even when I say 2 minutes, it's going to take longer than that. But we'll just wait for a few minutes until we get the first few solutions. Once you set these two things, that is the fitness, whether maximum or minimum should be tried to achieve by Galapagos. And also runtime is enabled with the duration. Go to solvers. Again, a personal preference is to display all genomes in RHINO viewport, which means every time Galapagos changes a number slider, I get a preview of it in RHINO. It's going to be very system intensive, but I'm just doing it so you guys have an interesting animation to look at. But for your system, make sure your system can handle that much power. Display all genomes in RHINO viewport is the setting I change. Not important, just a personal preference. And then start the solver. Now look at what's going to happen. You can see that the number slider that is connected to genome, which is the twisting of the tower, it keeps changing the angle. Every time the angle changes, you get a different radiation result in the panel. A preview of the animation is available in your RHINO screen. So when you're going for these kind of approaches in design, I would definitely say to take a time-lapse video, because when you're going to showcase your process to your jury or your client, they'll be more interested to understand how you came up with the final outcome that you achieved. And yeah, let's wait for a bit. It's going to take a few minutes. I'll also share some interesting examples where the strategy was used. I'm not sure if you guys are familiar with MOFA Architects. MOFA Architects is a studio that is located in Delhi in India. Yeah, I think it's in Delhi. I came across one of their Instagram videos where the whole planning process was optimized using Galapagos. So I am not sure based on what aspect. I think it was again based on how the radiation hits and different environmental factors. The planning was optimized to ensure that the building or the design is going to have maximum amount of shade or the interior is going to be cool. I'll just search through the Instagram video and I will share it across in the WhatsApp group after today's session. Go through it. It's a really, really interesting example. So let's do one thing. This is the last part of it. We would probably have to wait for 5 more minutes. Meantime, I'll just give you I can't use Grasshopper until then. So Ladybug installation will be after this. But I will give you a brief about the 11 days program that we have. So today's free webinar is meant more for you guys to get an introduction to what is parametric and generative design, and to get an idea how RHINO and Grasshopper are helpful in that. But if you wish to learn these softwares much more in detail, we have a 11 days structured program. I'll just run through it and wait while we wait for like a few more outputs here. Let me just open up our website. The 11 days workshop, it's a paid course. It is a much slowly paced session. So what we see out today is more to give you an idea, but the topics that we have seen, they all form different parts in the session. The parametric pavilion we saw comes on day 5. On day 6, we do a radiation analysis. On day 8, we do another kind of analysis to ensure maximum shade on the ground plane of it. So it was just like a snippets of different parts that we have in the session. But in the course, it is more organized from a beginner to an advanced level. So it is structured in a way you can come up with algorithms. Like you don't always need a tutorial or someone to teach you how to come up with an algorithm, but rather you start thinking how to come up with coding algorithms to generate a final design. We have a couple of batches, one that starts, earliest one starting from coming Saturday. And it also explains what are the softwares that we cover and the plugins. Primarily 3 softwares. Rhinoceros will be for 3 days, which is 12 hours. Grasshopper for 20 hours. And Maya will be for another 8 hours. RHINO Grasshopper, we saw what it is. Maya is helpful when you want to work on more fluidic designs. RHINO comes with certain disadvantages. Maya is to overcome that. Also, the tutor who's going to be handling the Maya classes is Akash Clive. He's had experience working with Zahadi architects. So he'll give you an insight on how the workflow is there using Maya as a parametric design element. So it's going to be more of a workflow based learning. And brief is same, it's 11 days course. We'll be looking into the softwares. And yes, you will look into not just like different workflows, but you will learn, like, I think there was a question, a workflow, how do you do a complete interiors or something? So you will see a workflow of how you start as a concept, how you work or understand the technical and the fabrication aspect. And you can also have it something as practically executed projects. So you'll be covering all those aspects as well. And we have a detailed day-wise schedule here, where day 1 is absolute basics. We just learn the interface of RHINO, like in depth. So it's just going to be simple box modeling. Day 2 is when we start with curves and organic surfaces. Day 3 is when we advance into more complex modeling techniques in RHINO, and to make it more precise and have like a proper model done in RHINO. Day 4, we introduce you to Grasshopper, the interface, the basic logics of it a lot more in depth. So you will start working on simple algorithms by yourself on day 4. Day 5, we look into Lunchbox extensively to see what are the different strategies you can use when it comes to creating patterns and modules. Day 6 is where we generate an entire skyscraper in Grasshopper. What we did is just like a twisted one. In the workshop, it's going to be more complex forms. And we analyze radiation, extract the plans, the fabrication data, everything. And on day 7, okay, I think the day 6 and 7 is flipped. The next session, we'll be looking into extensively on fabrication techniques and also how you can use mathematical expressions like sine, cos, parabola, those kind of functions in architectural forms. And day 8 is mainly a plugin day where you use Kangaroo. And remember the first example I showed you for Antonio Gaudi's Sagrada Familia? That form was done using Kangaroo. Kangaroo is used whenever you want to apply parameters based on physics, like certain loads, certain forces. You can apply those as parameters. So we see a few architectural examples, and on that day we use Galapagos again, where we create a roof using Kangaroo like this, and you see these anchor points of the roof. I wish I could pause it. I'm not sure how to do that. Right, so these anchor points that you're seeing, we optimize it to have maximum shape. And day 9 and 10 is going to be Maya with the final project presentation on day 11. So this is an overall run through. You can go through the website to get more in-depth details. And yep, our Galapagos is having some set of outputs. I'm just going to stop the solver for a bit. You normally let the solver run until the very last output. For now, I'm stopping it because I want to show you how you can get the details of it. And answering a question in chat, when can we get the recording? Within end of today. Right, I will explain you how you can access it towards the end of today's class. But recording will be shared within today itself to you guys. All right, so now we have like 5 to 6 iterations that was calculated. If I click outside, I don't see any radiation result. Every time I click on an iteration, there'll be a bunch of numbers popping up here, which is the fitness values. The best fitness value is on top. Worst fitness value is at the bottom. That is when I say Galapagos has to optimize for minimum number, the minimum radiation result on top, maximum at the bottom. For each set, it's going to keep on updating. But since it's a fairly simple algorithm, within the first few sets itself, it has found 30 to 170 as the best. I think even if I let it run completely, probably this is going to be the best value. But when you have more complex algorithms, each set will try to improvise the previous result. Now, how to find the number slider or genome that was used for each outcome is click on any radiation result here and then choose reinstate. When I choose reinstate, then take a look at the Grasshopper algorithm. I'm choosing 33983 and then selecting reinstate. Grasshopper gets updated, the radiation result is 33983 and the angle of twisting for that is 157 degrees. If I want to try a different number, let's try 32225. Selecting that and choosing reinstate. Grasshopper is updated to 32225, where the angle of twisting was 106. Similarly, go to the best result and choose reinstate. You will know what is the best angle to work with when you try to minimize the amount of radiation. That's it. So that's pretty much how you use Galapagos. You just change these parameters and choose reinstate and you get the result. You can try it for each set and then finalize on which outcome is the best one that will work for you. Any questions relevant to Grasshopper? Other questions in chat, I'll just come to it in a bit. But before that, any questions relevant to this specific exercise? All right, so I'm just going to hit OK and close it off. Now, one last thing you can do to complete this is, let's hide this one. Let's take a look at the twisted cover. You can go to the adjacent file. So I'm just going to choose File, Open Document, and choose the file that we just did for the pavilion, and hit Open. And what I'm going to do is I'm going to copy this entire algorithm, paste it in the adjacent file. Just go to top. You will see every time you do file open, you will see adjacent files here. Just paste it here. And once it is pasted, what I can do right now is I can apply this whole pattern that I had done initially. Instead of this organic surface, I can apply it entirely on this twisted surface. If you want to do that, you can do it too, and complete it as an entire workflow where whatever we have seen, we have put together into an exercise. And again, change the parameters like the number of divisions to match the form of this, and then see what's the final output. And that's it for today's session. I hope you enjoyed the session, and I hope you got something new to learn through this 3 hours class. I'll be sharing the recordings with you guys along with the resources for Ladybug I mentioned. In terms of Ladybug installation, when you download the Ladybug file, let me just go to my downloads. I had it downloaded right now. Yeah, so go to, when you download, you will have a zip folder. First thing, extract it. So right click, choose extract to, put it into a proper folder. You have all of it extracted here. When you open, these are the files. Installer is the main file. You can go to installation instruction. It will take you to this link. If I were to open that link in my computer, which is here, yeah. So if I were to open that installation link, it will take me to this page. So what you basically have to do is, it will say that you need to open the installer.gh file. When you do that, it's going to open a Grasshopper document. So if I were to show it to you side by side, if I were to show it to you side by side, you basically need to double click and open this file. When you open this file, you will have two components. One, in this Boolean toggle, change from false to true. Again, change this Boolean toggle from false to true. That's it. Double click on it, it will change to true. Once it is done, close RHINO, close Grasshopper, refresh your system. You should find Ladybug on top. Depending on the version, it will be a bit different. So right now for me, it says Ladybug. New versions might say LB, HB, they get installed together. They'll say LB and HB. Not a big deal. When you open this algorithm, if you have all the components opening up, it means that it's properly installed. You don't have any issue. So I will share this installation link with you guys from the Google website. You will most likely find it in the instructions itself. You just need to open and change to true. That's it. And the installation, I think, yes. Any specific learnings for the interior design in the 11 days workshop? Nothing specific to interiors. We do come across a few examples, specifically in the contouring technique. Contouring technique is the technique I use for fabricating this furniture that you're seeing. This is a design for an office cabin. And for this executive cabin table, I'm using the contouring technique. So we will see an example how you can use that technique, how you can create model, extract fabrication data, etc. But nothing very specific to interiors. But I would say RHINO Grasshopper is a modeling software and a parametric software. You understand the concept of it, you'll be able to do any kind of models. It can be architecture, interiors, furnitures. Even if you are into product designing, you can do that. It does not restrict you to just architectural examples when you listen in the workshop. You can still explore every example we saw in interior or furniture scale. Like for example, we did pavilion pattern. You can have an organic pattern on the interior like a feature wall, apply the same parametric pattern, you would still be able to do it. And when I was learning also, I just learned it as a software modeling tool. Only when I use it on my own projects, I used it in a way the same techniques applies on an interior scale. And also, since you get to work on some project works during the session, you can always feel free to, contact us for any guidance you require on how you can go about it. And yes, thank you so much. Thank you. I'm happy to hear that you enjoyed the session, guys. And after baking, why is prism? Ah, yes, that's a question I missed to answer previously. So once you're done with the exercise, so let's zoom into this. Okay. So once you're done with the pavilion or anything in Grasshopper, you will get to see something like this in web mode. Still not the most realistic one. You will definitely want to use a V-Ray or a Twinmotion or a different render engine. So what you do is, whatever outcome you are seeing in Grasshopper, you need it to become a RHINO object. So you export the output of Grasshopper to RHINO. You can do that by right-clicking and selecting Bake. Right-click the output, choose Bake, whichever component's output you want. Right-click and choose that Bake. Choose what layer you want to bake it into. Make sure group is yes, please. This setting of group yes, please will solve the problem that you had mentioned, why it is not selecting as a one unit. It has to be grouped, so choose yes, please, hit OK. When I select, get selected entirely. When I move it aside, I have it as a RHINO object. Now I can use any render engine and apply material onto it and take a final render. That's it. And mention learning extra plugin on request. Yes, you can let us know if there's any plugin you would like to learn in the 11 days course. We will try to incorporate it in the workshop. If not possible, also we'll make sure that we find some resources for you to understand it, and you can apply it when you're using your project work. So you get like a complete guidance of how to use it. How are these parametric designs constructed on site? You have something called as rationalization. Rationalization is a process where any design you do, anything complex or any kind of form you're doing, you break it down into a fabricatable object. So there are different techniques of fabrication, mostly accustomed to creativity of the architect, how we are using different elements. So based on that, you convert it into fabricatable geometry. For example, the surface that we created in RHINO, for this example, the surface that we created in RHINO, it is a very organic surface. Using panels on top of it is a way of breaking it down into fabricatable geometry. Now what I can do is I can take these panels, I can send it out for CNC cut where I get each of these panel modules, and then I can assemble it together on site. And of course, there'll be certain structural elements. You can't have panels floating in like this. You will probably have structural elements that will hold these panels in place together as well. So when you look at this, again, not one answer to how you go about fabricating, no. It's more of an idea or an approach you take to break down something super organic into simpler geometries, which Grasshopper will help you, and you use the tools to fabricate it. So we'll dive a lot more in depth in the 11 days course on how you do that. How to create voids in the pattern. You need to create an algorithm for that. So in the pattern, if you want some voids, depends how you want to do. So in a prism, there are like 1, 2, 3 faces. You can delete a few faces. It will create a void. Or what you can do is you can scale the faces into smaller sizes and make these scaled pieces a void, like you can trim it on the prism. So it depends on how you want to create void. You need to use algorithms to achieve that. And it has got an inverted pattern. How to fix it? Use a negative component. That's what I did. I used a negative for fixing the inversion. So if I didn't use negative, it went on the inside. You can see that the prism is on the inside. When I add negative to it, flips to the outside. And are there any plugins in Grasshopper to give structure of organic structures? You design the structure based on your understanding of how the form can be executed, but you have plugins which will ensure that the structure you have given is something workable on site. Plugins like Karamba and Millipede, they both will support you to optimize the structure as to what material will work and how much thickness, how much depth, and what should be the spacing. So basically the structural details of what will work in order to sustain that form, you can figure it out using plugins like Karamba and Millipede. So on the 11th day, we will learn how to build the paneling techniques, not just paneling techniques, a lot of different techniques, because if you look into parametric designs, like just a second, let me go to this. When you look at this, this is again not a paneling technique. This is like you create a module and that is assembled in a way to get this kind of form. So when you look at fabrication, it doesn't always have to be panels. Each example, you will have a different technique. Like take this one, it's a real-time building called as Bookworm Pavilion. It's an exercise we will look into in detail. It's a design done by architect Nuru Karim. So the fabrication technique they use there is, they have ladders at varying angles. Let me just show you the building. So if you look at the fabrication, it is multiple ladders created at varying angles and assembled together. It's not a paneling technique. So when you say fabrication, there are different ways. You will get an idea of how you can think of doing a fabrication for an object. And whatever strategy you're thinking, you'll also get an idea how to extract data and drawings out of it. So in this case, if you look at ladders, you have each ladder at a different height. You can see each ladder is of a different angle. The base width is also a little different. Like this picture is a really good example to understand the form. So all of these varying parameters, how you can extract the data and send it to the person who's going to be fabricating it. So they also understand and give you the exact same result. So these kind of things, you will get a better insight, and it does not always have to be just panels. Is Kangaroo and Kangaroo 2 different? It's just the old and the new version. Kangaroo is an older version. Kangaroo 2 is the updated one. And I personally prefer Kangaroo 2, and that is something what we would be seeing in the session as well. Thank you for guiding us. I'm happy to have helped you guys. And I hope that I get to see these outcomes. I forgot to mention an important thing. So in the registration, you would have seen you receive a certificate of attending the session. To receive the certificate, you need to do a couple of things. One, by watching the recordings, try to create an output with the workflow we have seen. You can try to do anything, a surface with a pattern, and you can try to do a different radiation analysis. Just apply the things we saw in class today, come up with an output, and you need to share it across in the Instagram page, tag us and mail us the same, and we will issue the certificate within a week. Okay, so the submission of this, you need to submit it within Wednesday. I'll send you the details of the submission date, the format, the mail ID, everything in the WhatsApp group. And that's it. I hope I went through all of your doubts. In 11 days workshop, do we get the recording? Yes, you do get the recording. All classes are live. It's going to be much more interactive because the batch strength will be lesser. We have like around 30-40 students a batch. And it will be live and interactive. Each live class is recorded and shared to you within 6 to 8 hours. Recording is available for 30 days from the end of the workshop. So it gives you sufficient time to watch through it, practice, and then master those skills as well. All right. Any other questions, guys, before we wind up? All right then. So thank you so much for joining in the session, and I'm happy to hear that you guys enjoyed it in the chat as well. And regarding the recording and everything, I will be sharing it in the WhatsApp group. Do keep an eye for it. Do not leave the group right away. Maybe a week or two later, but not right away. And yeah, bye everyone.